Okay. Hey everyone, Joseph, congrats on the first. New Machine Rex, hey. Love the Halloween peepo. Um, we're in chapter 6. It's exciting stuff. Let's get into voice. I see Stooky's here, let me drag them in. Hey Stooky.
There it is, morning.
Oh hey, good morning. How are you doing?
I'm doing okay. It's been a sort of emotional week, but
Oh,
the uh the weekend is here now.
yeah. um, Hope it goes better for you now then.
I think so.
Uh, Fembox, I'm not sure if Fembox just needs a minute, but were you able to read much of chapter 6 or?
I wouldn't say much, but
Okay.
something.
No worries. Um, this is I don't think I've had to use my right hand and like curl my fingers more like any other time in my life for chapter 6.
Oh,
I'm
good.
definitely gonna get confused on like whether these fields in a roundabout are going like clockwise or counterclockwise, but it, it is what it is, I guess.
Yep.
Um, do you have anything to say about like the part of it that you did read? I'm trying to remember if I had anything I want to talk about too.
Uh, I don't think so. It was pretty agreeable through the first couple sections.
Okay. I did think that Ampere's law was pretty neat, that it's basically like Gauss's law for magnetic fields.
Yeah.
Um,
Oh,
hey,
Hey,
Fembox.
Humbug.
how are you guys?
Pretty good.
Pretty good.
How about you?
Yeah, pretty good now.
Glad to hear it. Oh, and Suki, you're being given a hug by Mean Machine Rex.
Oh, thank you, Machine.
This morning I was freaking out because I had not read the chapter and I still haven't quite finished, but I made some good progress.
And one morning, you did the first 6 sections?
No,
Or
no,
about?
I was no,
Okay.
no, I was like a third of the way through it, and now maybe I'm closer to 2/3.
Okay. Um, those are the important bits. The last part of the chapter was actually 6.8 is like the smallest section I've seen. It's only like 2 paragraphs. There's a lot more like bonus stuff though, it felt like, rather than in like the real heavy physics was being done in the first part.
I felt like
Um,
that 6.7 might be important because it sounded like it was more relativity.
oh yeah, this one was kind of, yeah. Oh, this one was cool, yeah. Because you arrived to these pretty clean equations. Was there a different version? Yeah, we in 6.7. Oh, yeah, this is important that we get how the now we already knew how the electric field transforms in different frames, and now we know how the magnetic field transforms in different frames.
Hmm.
All right.
Um, okay, there's this. It was kind of cool that there's like the in 6.3 they talk about like the vector potential as similar to oh shoot,
Yeah, the voltage.
the voltage, yeah. But they kind of
Yeah.
like threw it out after getting to the result that they wanted. But it's kind of cool that analog still exists. Oh, something was tripping up is their like script J thing for current density, but within that like sheet of current.
Surface current density.
Yeah. And they made a point about how you would multiply the volume current density by an area. I think to get just the current. And then the script J, the surface current density, you just multiply it by a length. So I'm gonna have to like think about that once we actually like once it becomes an issue. But
Yeah, that footnote 10 talked about that.
oh right, yeah. But all right, I think that's everything I had to say about chapter 6. So, if there's anything from you two, we can start working on some problems.
Sounds
How do
good.
we pronounce Bio Savar?
Oh, that sounds much
I've been
more
saying
refined than I thought. I said Biot Savart, I think, in my head. That's will Google tell us? I feel like Wikipedia might have like an audio thing, right? Maybe it doesn't. Oh, 'cause the weird phonetic. Pronunciation. You might have listened to it through a stream, but this person's the deepest voice I think I've heard.
No, it's. Oh wait, no. Maybe it is.
Oh my god, he's giving me so much introduction. Beal? Beal? Savach. Something like that. Symbiote Savart still. Or Bio Savar would at least be closer. I'm glad I heard that though.
That
Sorry, what?
I'm used to those explainer or those pronunciation videos like almost being like computer voices. That was
Yeah.
a whole ass history.
It's kind of cool, but yeah.
It was cool.
All right, put the Excalibur link in the text chat for the voice chat here. Right, there's Doogie.
Oh, Dookie.
I'm working on it.
No worries. I'm reading the problem right now. I figured I'd start off with just like a little 1 star. It looks just like a calculation. Let's not get, you know. But let's hopefully we can start off strong. um,
Kilowatts of power. Okay.
oh, you know what? This is actually, I assumed it would just be plugging into formula or something like that, but it's actually not quite that simple, is it? Midway. So yeah, this is actually something a thicker line would benefit from. It's something like that. So I'm imagining, and we have. I guess a battery. Ah, why did I do it like that? And this distance in here is 2 meters. It's a big yeah, Chad, I was thinking that too. It's a physics drawing, okay? It's nothing perverse. Ooh, nice, Jed.
I'm just muting for a second because I might have to restart something here.
Oh, okay. I think from chapter 4, we know that power is something. I squared R. Or, yeah. Or IV, okay. P equals I squared R equals IV equals V squared over R. field midway
Okay.
between them. You can know?
Yeah, sorry, I had to close about 50 tabs. My computer wasn't working right.
Okay. Is this illustration accurate? I would like to think so, Jed. I can't promise that though. I mean, it might actually be looping on itself. It might actually be just two separate wires. You'd flunk out. I don't know that we're doing all that well either, but is it actually like being split in two? Maybe it's so I guess the positive end is the big end. I don't know if it matters, but maybe it's actually something like this. And that distance is 2 meters. I don't know if the actual entire circuit is that important to think about.
Yeah, I mean it just depends about like whether they're going the same direction or the opposite direction. So there's something to think about, but it might just be the attraction versus repulsion, which I guess technically we don't need to we can be agnostic about.
Yeah. Wire conductors. So I wonder if this 50 kilovolts is being split between the two or not.
Oh, I see.
So we can do 10 megawatts equals current times 50 kilovolts and get the total current.
Mhm.
I don't know whether it's. I would assume it's being split. That feels right to me. See if Wolfram Alpha
Fair
is
enough.
feeling good about the units today. A kilo ampere. So 1,000 amperes is I. Because the line is transmitting 10 megawatts of power. Yeah, so I feel like it's 5 each. Okay. So then I think I'm making the claim that we have 500 amperes each, presumably going in the same direction here.
Hmm.
Jed was thinking a straight line of length 2 meters. I don't see how that would be.
I liked your first picture.
Where it loops on itself? I mean, I don't know if it's fundamentally different than this. Oh, wait, no, I guess it would be. That would flip the direction.
If those two currents are going the same way, then at the midpoint, it would be a zero magnetic field, wouldn't it? Because they would interfere with each other. I think.
I was just thinking about that.
Yeah, the right-hand rule.
I see. Right. Okay.
Oh. Yeah.
So maybe we've got 1,000 amps going right and then curling around and 1,000 amps coming back through the bottom. I don't know.
I do think they would
Yeah.
cancel on my drawing, yeah.
I'd be happy to do that.
I guess we can go with the first drawing. Next on that.
Oh, okay.
I don't. I mean, unless there's something about that drawing that we can salvage, but I don't think it's. I think Pemlox is making a good point here. It's that 2 meters apart thing, Jed, that makes me think it might not be what you're saying. Hey, Anand, I'm good. How about you? Hey, Cook.
Dr. Cook, hello.
Oh, no worries. That was like a big thing to offer, so I don't expect you to like instantly reply or have it all figured out. And so if we have this situation, they should be. I guess we could just calculate it for one of them and multiply it by 2.
Think so.
Yeah, we got Fenlux and Stuki here today. It's going pretty good.
Yeah, going well.
Just started on chapter 6 for the first time and we're in this 1-star problem.
I just went to my school library a couple days ago to look for physics books, and they had one called How to Teach Relativity to Your Dog.
Sounds like it's suited for me. That's chapter 4.
I didn't borrow it. I borrowed something else instead.
I mean, it sounds kind of funny though.
Yeah, they had quite a few books. They had more than I thought they would.
It's the field due to long
Oh,
straight
Hartle.
line.
I didn't look for Hartle.
Una I over
But I found Hartle on the Internet Archive when I was looking this morning.
Una, and then we're saying I is 1,000. There's asking about strength, right? Yeah, how strong?
Right.
Or 2 pi times 1 meter. And that is a number that we can find. What is mu naught called? I can just get the actual
10
number.
to the minus 7 times 4 pi.
Oh, I have it right on the... Okay. It's right on the screen. Times 4 pi times 10 e minus 7. Times 1,000, and then I guess
4,000. 4 times 10 to the minus 4 Tesla? Is that what it turns into?
10 to the minus 4 Tesla. Wait, sorry. 4 times 10 to the minus 4. Which is what you said.
Isn't that exactly 4 Gauss? Didn't I read that that's 10 to the minus 4? Or have I got that backwards?
No, that's good.
Something like that. All right. I guess we can check the answer here.
Okay, let's hope for a win.
Let's, yeah. I chose once we hope we get off to a strong start, so let's see if that worked. Oh, wait. We're off by power of 10? Did I just do an entry? No. 200 amps is the current. What? Oh, wait. No? Joules. Did Wolfram Alpha mislead me? Or did I make an entry error?
10 megawatts and 50 kilovolts.
100 seem
50.
right.
Oh,
Um,
I put 50 megawatts in from alpha nut. And it's 0.2. Okay, I just made it. Okay, we had the technique right, I think. Then I just
Yeah.
messed up the entry like usual. Oh yeah, Cook, if you're still around like for after, I definitely wouldn't mind talking about it. So what needs to change over here is that becomes a 200. Good exercise for this chapter? Oh yeah. Wait, did they have a factor of 2 there though? We might.
We were out by 10.
Oh, the field due to 1 wires then.
okay.
They multiply by 2 after. So the 4 is just a coincidence. Getting the 200 here is going to change it. We expect to get, for the final answer, 8 times 10 to the minus 5. 0.8 gauss. Need my mu naught again. 4 pi 10 to the minus 7. Times 10 to the minus 7 times 200 over 2 pi. Okay, and that's our 8 times 10 to the minus 5. Okay. So typical me just sabotaging us with entry errors. Okay. The next one I had pulled was number 3. Tim Cook is going to need a minute to put his thing there. Oh, there's some rearrangement here. Okay. Suppose the current I2 in figure 6.4b, hey Anders, is equal to I1 but reversed. Oh god, why did I pull this one? Suppose the current I2 in figure...
So let's see.
Where's I1? Oh, what was happening in this figure?
It's like 2 figures in one. We're just looking at the
Yeah.
bottom
What?
2 wires with the U shape.
Okay, yeah. I see, and there's a straight wire and then the U-shaped wire. Okay, that's our I1 and I2.
Yeah.
But I think I still grabbed 6.48, they make reference to right there, so that's probably why I grabbed it. Yeah. A, B, and EF. Lie vertically above
vertically
GH.
above GH.
Okay.
The lengths BC and CD. And they're not. And then the sides are different lengths, so I2 is going to be at an angle on the bottom.
No, wait. BC and CD.
BC. Oh, CD. I see. Okay. Never mind. BCDE.
Oh, I like this question.
So we're putting these two things on top of each other. What's the like the distance between them is 0.5? That's the deflection, no.
Right. So the like straight on view here is that if you have like AB running there and you have GH running here, then that little loop is doing this, running that way for a little while.
Okay. Yeah, it's being pushed off to the side in that distance point. Okay. Or 0.5. So this is like a statics problem then, where
Yeah.
the force due to gravity equals the magnetic force.
The component, yeah.
Oh, right, the vertical component of the magnetic force. Because the sideways force still exists, and that's why it's being deflected.
Okay.
Just meeting Discord for a second. Sark over on YouTube, you're new here, want to get into astrophysics. Any tips for that? I haven't studied astrophysics for myself, so I'm not sure, but like I haven't studied E&M in physics, and it's just been super fun to get into the math. So if you can find a book that like challenges you and gets you interested, that's for physics generally. Okay. Yeah, I mean, this has worked for me. Is I'm really interested in the math already, so finding a book that speaks to that math has gotten me really enthusiastic about it. But you might be interested in a different aspect than I am, or kind of for a different angle. So maybe like watching like documentaries or something like that would get you like motivated. I'm not sure. I've ended a problem like that already, Cook. To be honest, I haven't thought it through fully though. But 6.3. Hey, Athar.
30 centimeters, 0.5 centimeters. Okay.
GH.
How do I make my pen thinner? Oh, over here.
Yeah. Oh, nice. Welcome in, Arthav. Or Atharv, I'm sorry. Should CD be shifted up a little bit? Like somewhere up there?
I was thinking CD was going to be like horizontal from GH. Is that what you guys were thinking?
Oh, it could be that. Huh.
I think that's how they set this up when I remember reading it.
That's why I was like curious, because like I guess we
Yeah.
do they say what the height is from AB to GH? That'd be nice.
Well, let's see.
It might have to be right triangle, otherwise we don't know how to solve this. So we need an angle.
Oh. So how does this little guy work? This B, C, D, E, this little U frame, right? How does it work at points B and E? Is it sort of free to rotate right there?
Right.
So it's
I
sort
think
of like
so.
a little, okay, so it's sort of like a little hinge at point A, isn't it? So
Yeah.
We just don't know if they're at like the exact height where the wires would be touching if there was no current or what.
So it would be something like this. We'd have a weight force. We'd have like a tension in the metal, and we'd have a B this way. Is it B?
Uh,
B's not a force, is it? It's QV cross B or something.
yeah.
Um,
Oh, do we have to consider the? I guess there would be tension from the wire. Oh no.
I mean, we know okay. From the geometry, we can work out all the angles in that triangle, right? And we could work out the height AG if that vertical height if we needed it.
Mm-hmm.
So the geometry of the triangle should be the same geometry for the forces. So we could draw this in a force triangle, right? Like, and we probably don't need the tension, right? We just need the angle, maybe this angle theta down here.
Yeah, the tension should equal gravity, I guess. Or this the
The angle's theta.
yeah, we should need the tension.
So I could just move the weight up there and it should close that triangle. And we can work out the weight force. And we know theta, so we can say tan theta is W over B.
Right.
How about that? Is that a good idea?
Seems good.
I think so, yeah.
And we're looking for, so we could solve for B. Now, how do we write B in terms of current?
I think the same equation I wrote in the last one. B equals mu naught I.
Oh, because my B is wrong. This is, what was it? It's Bill. I remember it's Bill because like we had Joe and the other one. Now we got Bill. The force is BIL, right? So I think this force should be, if I call this F, I think that magnetic force is B times I times the length, right? Is that right? The magnetic
B
field
times
times
I
the
times
current in the wire times the,
Bless you.
Thank you.
I mean, we're just given the magnetic field due to current carrying wires mu naught I over 2 pi r. I'm trying to remember where the Bill
yeah, so
thing
we're
comes
going to need
from.
that too.
Oh, F equals
I think,
I2B1L?
yeah, I think that was when you had two parallel wires with the same, was it the same current in both? Or maybe it doesn't have to be. I remember they said like the current in one puts a force on the other and vice
Right.
versa.
Yeah, and that's the situation we have here. We're thinking about how much the current in I1 affects this hinge contraption.
So we got B in terms of I, we got F in terms of B and I, and we've got this relationship between theta and the weight and F. I think we got enough to solve for I here, right? If we put all these equations together. Let's see.
I2.
Are we just given the I as a constant?
No, I think we,
Oh wait, how large is the current? Never mind, they're asking us to solve
yeah,
for
that's
that.
our question. We had to find it.
We know R, and we can set it equal to the. I guess we would need a magnetic force times like sine theta, depending on what we're calling theta. Um,
Yeah, equals. over tan theta. And then I want to plug in this equation for B. Mu naught I squared L over 2 pi R equals weight over tan theta. So I squared equals 2 pi RW. Is this looking good? Stop me if this is not right. Over
I think we're cooking
mu
low.
naught L tan theta. And what's the weight? mg. Is the weight just mgl? The weight is 0.08 newtons per meter. Okay. What's R in this now? I feel like I know what I'm doing, except for what's R stand for here? Is R the 0.5 centimeters?
Yeah. Because R is the distance between the two wires in that formula.
Hey, Slow Turtle.
2 pi.
Oh, I see where this bill thing comes from. Okay.
Now what's this weight? 0.8 newtons per meter. And what was the length? 15 centimeters? Can I just cancel out the length here? I think I can say that the weight is just 0.08 times L. And cancel out that length.
Cool.
And then what's the tangent? Well, we just go and work out. I don't know, what is it? It's tan of arc sine of 0.5 over 30. Tan arc sine. Oops.
Which are sine, arc, cosine, cosine.
Oops.
It's a number that's very close to 60.
There's mu naught 4 pi times 10 to minus 7.
Right.
Times this awful tangent thing. So what do we get here? It's gonna be a big number, isn't it?
I guess this is about time for Wolfram.
Yeah, that number is very close to 60. It's 59.99.
Okay. Forty over 220, 2,000 over 60. Can you say that again, Stuki? What was that number?
59.992.
This is I squared.
Right.
Getting 1 point, I guess, 2 times 10 to the 5th. Oh, I used the step from before last. Oh, actually, that's too high. Never mind, I must have... Did I make an entry mistake? We're assuming in degrees instead of
No,
ratings or
it's just
something.
the arc sine should be an arc cosine.
I think I did something wrong. Yeah.
Oh.
Oh, thank you. Because I'm
Okay.
sitting there saying, what's going on? That was cosine. Thank you.
33.3.
$33.33. Yeah.
And that's I squared.
Yeah. 33. Oh, yeah. Sorry. Yep. You got it.
Oh, sorry.
So then we just take the square root, and I got like 5.774.
That's right.
I guess 5.8 we can call it amps.
Yeah.
Real quick. The what are the units here?
Don't the so yeah, the weight force, he said it was just 0.08, but that was newtons per meter. Do we need to multiply by the
Right.
length of the wire?
What I did was I
Uh,
canceled out the length at that point from the top and the bottom, which I did that kind of quickly, and I don't know if I was right to do it.
Where did that come from? From Bill.
Yeah, is that wrong? Let me think about that.
It's
you're
not the same
using
length.
Yeah,
W is MGL. Or
yeah, I guess that's what I was doing. W is MGL.
L times like density. um,
G, yeah, L times linear density. Or whatever. Linear, whatever.
yeah.
uh, and is that the same L that Fenlux canceled with? I think is the question. And I think
Yeah, I was thinking of that point CD as kind of like looking at that wire section CD, right? That whole 15 centimeter piece of wire.
so F is the magnet, or F is the force of the I1 wire on the I2 wire. But
Agreed.
we're just having that, we're just letting that be an arbitrary length though.
Yeah, it's like this is a force per length, right? That's how the units work out.
For W, or that's what they gave us, yeah.
For B.
For B. I think for B, it's not per length. Or we wouldn't want per length.
Yeah, that's right. Okay.
If the weight is 0.08 newtons per meter, we would have to multiply that by the length in meters to get a force in newtons, right? and that's the length L. I feel like those L's can cancel.
Do we have to include the weight of like BC and DE? That would get complicated though. I feel like we wouldn't with how the tension works. Because I think that's a calculus
the-
problem.
Yeah,
Then.
I'm hoping.
So the triangle, the force triangle I drew, right? I was trying to think of my free body as being the little 15 centimeter piece of wire from C to D.
Right.
And just thinking of the weight of that wire, the magnetic force of repulsion on that wire, and the whatever is required to hold it up.
Yeah.
I think it maybe makes sense that we can cancel the length because we could always we're already letting that I1 wire be arbitrarily long. So we could do the same experiment for any length of CD that we want.
Right. And
Maybe that's why it doesn't matter?
expect that if like the contraction got longer, you wouldn't expect that to like get closer.
Or yeah, like
Cool.
anytime you increase the length of CD, you would increase both the weight but also the magnetic force that it experiences. I assume by the same rate.
Right.
So I think I'm okay with this then. I don't see. I mean, we haven't gone through like the units from scratch, but I think this will be okay. I don't know. Are there any objections by look at the answer?
Okay. So yeah, one last thing. I'm worried about this tan of our cosine. So the reason that that comes out to be 60 is that
It kind of
basic
makes sense, right? It's basically 30 centimeters both sides, basically.
right.
Yeah.
Yeah. So my question is, should that be in centimeters then instead of meters? Or has that been accounted for somewhere else in the formula?
The tangent of the arc cosine of the ratio of the two side lengths, right? As long as the two side lengths are measured in the same units, then that's just a number. That's dimensionless.
Yeah.
Okay. Okay. Cool.
Can just a ratio. Okay. Yeah, I feel like I'm the quickest out of us to try to look at the answer key. But what?
What about is the equilibrium stable? We haven't discussed that.
Oh, sure.
Well, we were assuming. I don't see why not. I guess.
Yeah, it feels like it would be, right? It feels like if you came along and pushed it a little bit towards the other wire and let it go, it would just sort of spring back like a spring.
Yeah.
And if you pulled it out a little bit, gravity would swing it back towards it.
Yeah.
Yeah, I'm bad. I mean, if I hit a problem and I don't know how to do it, usually I'll just shelve the whole book. I never look at the answers. I'm really bad about it. I really am.
Oh no. They might be considering the entire mass of the wire, including the sides. The location of the center of mass of BCDE.
Uh-oh.
Gross.
We're already off to a bad start, I think.
Oh, yeah. Wait, do we have to do that? Yeah, because the other wires are being pushed out as well, aren't they? Oh, yeah. Sorry, guys. I didn't even think of that.
I was just
Yeah,
hoping
you
we
know, I'm
wouldn't have to
treating the
deal with that.
okay, so you know what I've done? I've treated the problem as if it was a wire segment on two strings, haven't I? Like massless strings. Yeah, that's all right. Well, we can fix it.
Yeah. It's just I don't know how to fix it.
And we know this seems positively
Hmm.
disgusting. Um,
Well, instead of, okay, yeah, the center of mass, it said, right? Yeah. Jeez.
oh, right. Okay, well, so some of if it were just going directly downward, we could ignore, like, there wouldn't be any magnetic force because of that current, right? Because it's not going the right way. Um, does that true even though it's at an angle?
Can you say that again? I didn't understand. You're saying
Um,
the two like hanging segments of wire?
right. So I'm worried about the current that's going through them.
Oh,
I, well, they don't interact magnetically because they're perpendicular, right?
Still perpendicular. Oh yeah,
Um,
yeah. Even if with the tilted angle. Okay. Okay. So yeah, what all changes? What
so I think the
changes?
only thing that changes is W.
W, I believe that.
So we have to consider it like the entire length of BCDE
hmm.
and look at the center of mass, which is annoying.
Okay.
So, wait,
Well,
why do
there,
we care about the location?
Because I think that's gonna change what uh
yeah, we could think of the whole little U frame as if it's a point located at the center of mass, couldn't we? And that's where the weight
So,
force would act.
right. But the other two forces are not there.
We got the same magnetic force, right? So that magnetic force is now instead of just pushing the CD wire out by half a centimeter, it's sort of rotating the whole U shape. Oh,
this is I, I'm only caring about the location of the center of mass because the book says to. I don't get what we change.
Yeah.
okay. How about this? If the wire CD got moved half a centimeter, right? And we can work out its mass, or we have the weight per unit length of the whole thing. The two other wires, BC and DE,
Mhm.
can't we just argue that they hmm,
Is this leverage?
so-
like there's a hinge at B, then
Yeah.
the vertical wire is like this, and then gravity's acting halfway in the middle, and the magnetic force is acting at the end. Is that what we do with this?
What do we do with this? Uh, sure feels like it.
Hey, Impertep. Impertep, I see what you're writing, but I think we need to make a bigger modification than that. I should have drawn this vertically, but
Oh, I like that, Don. That's a really nice idea. So you're saying, yeah, so you're saying we take moments about point B basically,
I guess so.
or moments about that line like A, B, E, F. If we think of the whole U frame is hinged on that line, we can kind of take moments about that line, right? And then we could break it into, we could just think of it, instead of finding the center of mass of the whole U shape, let's just make it 3 different masses, right? Each one at its center, because that's easy to do.
Hmm.
So all we got to do is throw on 2 more weight forces down, don't we?
Oh, I see.
Yeah, we only did the CD weight force. And part of the forces from B, C, and D, E are being offset by the hinge? Or is that not right? I'm trying to figure out if the angle actually matters for them. Or like where it's
Yeah,
acting.
the angle matters. So it's the same angle because couldn't we just add all those weight forces onto the weight force we already had? Don't we just have to multiply that weight force by 5? Because instead of 15 centimeters, we got 75 centimeters total now? Or is it not that easy? It's probably not that easy. We probably have to think of moments about the hinge.
Yeah, because I
Yeah.
think it's easier to just slide the vertical wires to the side a bit than it is to move the entire CD length to the side. Or like just, it's easier to tilt B, C, and ED.
Yeah.
But if we did compute that angle, oh yeah, I see Stuki's already drawing something. I think we only like there's a right
Yeah,
triangle.
this
We just want
picture's
the
great.
bottom part of it. Yeah.
I think that picture is going to give us enough to solve it now. Those 2 weight forces are half as far from the hinge, aren't they? As the one we had before.
Right.
Instead of half a centimeter, there'll be 1/4 of a centimeter each of those. So couldn't we? Yeah, because I was going to multiply by 5, but couldn't we multiply by 3? Because if we kind of put those 2 together and then slid them out to the same point that we were working at, we'd have 3 times that weight instead of 5 times that weight.
I'm down with that.
Yeah. So what does that mean? Our answer gets tripled? Well, radical 3. We're going to have radical 3 times what we came up with. That's what I think.
Hey Lucas, insane Zlitchy, if I'm saying that right. feel like I'm kind of, you probably already figured this part out, but because I wasn't quite following. Like, if I draw this right triangle down here and the hypotenuse are these vertical wires that are tilted a bit, like the hinge and the vertical component of gravity are perfectly offsetting each other, I think. And then left and right are f sub g sub y, I guess, and f sub g sub x is being offset by the magnetic force. And then, so we want like cosine of this angle here, and I think it's the same angle that we had up there. That I don't remember how you worked it out. But can we do the? I guess two, because we have two vertical wires, but 2 times the length of the wire times 0.08 newtons per meter times cosine of that angle, and that's what we want to add on to our weight force. I'm sorry, that's what you already said, and I'm just, I guess, like, we said is g times, or like just for the one that we all agree on, that's CD, g times lambda times L plus 2 times g lambda different L 30.
Yeah.
I guess. Times cosine, and if it is that same triangle, 0.5 over 30. Well, I'm not quite clear on that.
Whoa.
Something like that is what I was thinking.
And this is...
Why do I need the cosine in here?
Because part of the weight of these things are being offset just by the hinge. The magnetic force isn't doing anything for that. That's, I think, what, that's my rationale at least.
If the magnetic force is horizontal and all the weights are vertical, then isn't the hinge holding all the weight?
I think so.
Yeah, so Don, in your triangle, you've got the force of the hinge going up. You've got the magnetic force going to the right. And then you've got FGY and FGX. So what are they? The weight force Y and what's the FGX?
Oh, gravity doesn't really do that, does it? It doesn't have a horizontal component issue. I was trying to split, because the wire is hanging, like, I was imagining, like, this hypotenuse is the actual, like, wire, and I guess gravity is only acting directly down on it, though. That doesn't make...
Right.
I guess the hinge is what's maybe resisting the... I don't know. I'm lost.
Yeah. I think that sentence was correct.
The hinge should be right here, and then
Yeah, okay.
God knows what goes for the up force there, but
Well, that would also be the hinge. I mean, the hinge is going to
Okay.
hold both of those.
I don't know if this helps. Well, I mean, does that transitively mean that FG equals FB?
Well, no, because the F hinge, those aren't the same F
Oh,
hinge, right?
yeah,
There's a
yeah, yeah.
F hinge Y and an F
Okay.
hinge X.
Dang. I don't know if this is helpful then. Sorry, I see what's happening in chat, but I'm like, my brain's hurting a little too much to follow that. Welcome in, Delamorte.
I think this is plan.
I like in Stuckey's picture, you know, if we think of those three different weights, the BC, the CD, and the DE, and the BC and DE are each twice the CD, aren't they? Because those wires are twice as long. And
Right.
let's just run with Stuckey's picture and take moments about that hinge point. I mean, that should give us everything, right?
If you know how to do that, then please do. I don't.
Okay. Okay, let's do that. Because we got the same geometry we had. How do I copy this picture?
The selection tools, that's on like one, and you can drag a box around it, and there's like Control C, Control V.
Oh, oops, it's not it.
Okay,
Thanks.
it sounds like Cook
That
agrees with
worked.
this torques thing, or like balancing the moments.
Yeah, so what's the point at the top? A, we'll call it A, yep. Some of the moments about A should be 0. So we've got, let me just put an angle in here. This angle here, is this the one I want? Which angle were we using before? Yeah, that's theta. So I want FB times 30 sine theta, is that right? Equals, I'm not gonna have enough space here.
Oh, we can slide stuff over if you need that space.
Equals 2 weight BC, because they're both the same, right? BC and DE
Right.
times so that's going to be those are 0 point. So if I'm working in centimeters here, this is 1/4 of a centimeter, isn't it? Plus weight CD times 1/2 centimeter. Okay. So So what do we got here? This weight is going to be 30 plus 15. Did I lose the 30 sine theta here? Sorry. Like my intention here, all the links are going to cancel out. Or I mean, the dimensions of them should cancel out. As long as I keep everything in centimeters, I think I should be okay. EIL is 1/2. So what do we got here? We got 0.08 times, was it 0.08 or 0.8? Sorry. Yep, 0.08.
Yeah.
Plus 15.
All right, these units should cancel.
And we got to bring B back into this.
Well, is this the calculation? That's what we already had. That seemed okay,
What's
right?
B again?
I guess we need to rearrange all the terms again. B is mu naught I over 2 pi r.
That's still gonna be the same.
Yeah, like that.
And I really should put the L in here if I plugged all these L's in. I should have left everything in terms of L. I just used L and 2L. So my L is 15. So, and my R is 0.05, isn't it?
I think just 0.5. Oh, 0.5 centimeters.
0.5? Yeah, 0.5. Thanks. So these cancel. 15 into 45, 3 into 60, 20. So I squared equals 0.08 pi divided by 20 mu naught times sine of this angle, which was
Okay. Sine or cosine?
is it cosine?
You were doing the x direction or the y direction? The y direction. Right?
Let me just look at what I did there. FB 30. I think I had it right there. I think I want sine here. So it should be that same. It's going to be sine of arc cos of 0.5 over 30 again, isn't it? I think so.
Okay.
Did I royally botch
Yeah,
this?
that makes sense. That makes sense. And that number is 1.
Yeah. And the mu naught was 4 pi times 10 to the minus 7.
For the entire answer, I'm getting 10,001. For I squared.
Well, that's a lot bigger, isn't it?
I like 10,000.
Result in radians. Oh, yeah, because they use radians for that. That's fine.
Looks good.
80, that's a 10. 10 to the 5, 10 to the 4 over, I think it's 10 to the 4. Yeah, what'd you say you got, Don?
10,001.4.
Yeah,
And that square root's
Right.
Sounds good.
basically 100.
that made a huge difference. Before we had, what did we get before? Like 6 amps?
5 or yeah, 6 amps more or less. I have 100. Just gonna write the what I get for I down below here.
$100.007. Okay.
Did I get 2? Well, that turned out to be a lot more mechanics than I thought it would be. That I don't remember how these torques work, but I'm glad we have you here, Fembox. Are you still checking something, or should I look more at the answer key?
I mean, provided there's no mistakes with what I wrote, then I guess we're done. Why did that make such a huge difference? I mean,
So the big difference here is that for some reason we're not multiplying by 0.005, so 5's half a centimeter. And
why do I feel like I
instead
screwed this?
we're multiplying by a half. So that's the difference here, which feels bad.
Was a
Oh
half?
wait,
That was the only issue? Oh, I guess you
right,
don't.
because before it was 1 over 20,000 or 2,000 or something. Right?
Huh.
So
Yeah, I wanted to keep everything in terms of centimeters when I was doing the moments, just so I didn't have to worry about the decimals, but I may have got myself in trouble somewhere.
that 1/2 is where did that 1/2 go? Oh, it turned into this 30. Okay. So that's like a half a centimeter divided by 30 centimeters. That feels right. Feels like oh, but then
We are increasing the weight by a lot. We should need a stronger current to hold it up.
right.
Yeah.
This one is in plus 15. Is this an issue? Newtons per meter, and this should be in meters.
Oh,
Yeah, I wonder.
I mean that's a very easy fix, right? It just
yeah, where that's probably throwing off an order of magnitude.
Oops. Would that get us back to 10 from 100? That feels better.
lose. So this would become 10 squared instead of 10 to the 4th.
That feels
Yeah.
better. Okay, so I'm just gonna say times 100, 100. Squared. Oops, the pen got big again. It feels better. Let's see. 10.000 amps.
That's true. So some YouTube chat called that like ages ago. Okay. So that's a
Yeah,
little
that
less than
felt too
doubling the
big.
previous
Okay,
answer.
good catch.
Okay. All right, let's see if this is right.
Yeah, let's check it.
Uh, 10 amps.
10 amps.
Nice.
Nice. Hey, Yanis. Yeah, I'm sorry. Only for another half an hour or so, though. Equilibrium is stable because large angle uses small magnetic torque. Yeah. What's this last paragraph saying?
Look at that awesome formula for current.
In the last paragraph here?
Yeah, at the start of the last paragraph. Yep.
Awesome is one word, I guess. Why is this important? I'm trying to figure that out.
I guess they're just saying it comes down to being proportional to R. I is proportional to R. I decreases if both H and L are scaled up by the same factor.
What are they calling? H is the height of BC, L is the length of CD. Oh, I guess because increasing the length of like CD, the horizontal wire, kind of increases the magnetic force a lot. It increases the magnetic force much as it increases like the gravity. Whereas adding length to just BC only increases the gravity. That might not be quite right though.
Oh yeah, that's right. Because initially when I'd done it incorrectly, we thought that that distance of CD didn't factor in, right?
Yeah.
But that was my mistake because I treated it as if it was like hanging from strings.
Right.
Hmm.
And they're basically acting like strings, I guess, for how like the physical movement is. But if they're not quite perpendicular, there shouldn't be like a slight magnetic force. I'm glad we don't have to consider that, but I feel like
Well,
I
they're
don't know.
still at right angles to that bottom wire, though, aren't they?
Oh, I
Right.
guess
The
so.
current.
Yeah. It's okay, yeah, that's fair. Like the V is directly in line with B, so V cross B is 0. And that's the important part. Okay. Should we try to do one more?
Sure.
Do it.
I think I'm gonna do Excalibur going because that one's gonna get laggy. Gonna put it in the same spot. Before I forget, download an image of this. So I almost messed it up last time. Okay, so the next one
When I closed all those tabs, I closed a bunch of old Excaliburs, and they were still there. They were still there. Yeah.
Oh wow. Okay, nice. That's good to know that we wouldn't lose it forever. I didn't make another mistake like that. Um, so this is just another 1-star problem, but it seemed kind of interesting. So a current I runs along an arbitrarily shaped wire that connects two given points, as shown in figure 6.35, and need not lie in a plane. Show the magnetic field at distant location is essentially the same as the field due to a straight wire with current I running between the 2 points. Oh, Stuka, are you able to find the link?
I see it.
Oh, is it not working?
There it is. Okay.
Okay. Sorry, I just didn't notice that you weren't in there. This feels like an argument we're in like chapter 1 about how you do like the same amount. If you have like a point charge with an electric field, oops. No matter what path you take, it's always the same as if you just did a straight line from one point to the other. And it feels like I think an argument like that. There's going to be some kind of like cancellation or something. Dr. Cook is saying start with Bio Savar. Hey, Speedcuber.
Bio Savar.
Savar. Let me.
You got to say it like you're being strangled.
Yeah, that's what it feels like. Around this loopy wire. Alright, I found it. Let me. Oh, I don't have my snipping tool up. Dr. Cook wants us to put A and B on the x-axis. DL cross our hat. All the y components will cancel. Okay, yeah, because if we know we have to start at A and end at B, so if we like do something weird and come up, we do have to come back down. And it's this DL cross R thing where we should like get some kind of cancellation.
So we're thinking about R as being like far into the page here.
R, it's a good question. I guess, is R always
distant
this
locations.
vector? Or is it like whatever point we're at? I guess whatever
No,
point.
R is the vector. R is the vector from your little DL piece of
Okay, yeah,
wire
that makes more
to your
sense.
test to where you're trying to measure the field.
Yeah.
R is sort of
Get a unit vector. Oops. Oh, well, now it's pointing. Never mind.
Are you making those R vectors go to point B? Is that what it is?
Oh, wait, where are we? Oh, where have I? Oh, shoot. I see what.
I would think we would
Never
be
mind.
like a long way away.
Yeah. Cleveland likes R vectors anyway. Okay, DL is like that, and then we would have to name some point like over there or something that's R. Or yeah, we can do it up there. It doesn't matter.
Yeah, way up there somewhere.
R. R.
Mhm.
Cook is going on to say, I think the idea is that the 1 over r squared can approximately factor out of the integral when you're far away, the integral being the one from the Biot-Savart law.
Right.
Assuming distance weighs much larger than characteristic y dimension of the loop wire. Oh, because from a far distance away, this, like the bit of the wire at the top being closer doesn't really matter.
Right.
We could just take it as a constant. Okay. Factor 1 over r squared from the Biot-Savart integral, then only the cross product remains inside the integrand. Those blue r vectors are not good. Let's first specify the point at which you want to compute B. Then draw. I mean, I think we're hypothetically putting. Maybe they look a little bit too parallel, but we're putting some like blue dot, like I guess, way up above the problem or something like that for where we're evaluating it at. Speed Cooper, yeah. About advanced undergrad. Call them R hat. Okay. Oh, the full length? Okay. That's fair enough. So great distance away from the wire. R is approximately constant. So I guess the entire magnetic field is equal to the integral of that. Mu naught I or 4 pi r squared dl cross r hat. And do we, is this an integral that we actually can do? Actually,
Maybe we break all our little DLs up into DXs and DYs. Or actually, I mean, not to rain on our parade here, but they did say this doesn't even have to be in a plane, so
I was wondering about that too. That we're
it could be DXs, DYs, and DZs, I guess.
yeah.
But we want all the Ys and Zs to cancel, I guess, right?
I think like my drawing aside, or like my two-dimensional drawing aside, we could say this argument still holds for 3 dimensions. Because for this cross product, I guess you have to add on the 3rd dimension anyway. Like, we can still take A and B as on the x-axis, and argue that the y and z components should cancel somehow.
Yeah, can we just can we do this? Can we do that?
Oh, I don't know. I don't know how the cross product works like that.
The logic is that r hat is also essentially a constant.
Isn't it changing where it points?
Well, it barely.
Oh,
It's
okay.
pointing upward, right? Like,
Yeah, for very far away.
mhm.
Well, I like that a lot because now if you
Okay.
can do that, then you can change DL into DX plus DY plus DZ. And then just argue that if you're going from A to B and they're both on the x-axis, then all the DYs and DZs have to sum up to 0, right? I mean, over the
Did you just say
whole.
our head is a constant? Sorry, $10.
Yeah, see, that's the thing about our hat. It's like, where are we? Because we don't want to be too close, otherwise it won't work. But if we go too far away, if you let the point go to infinity, then the magnetic field goes to 0 anyway, and it's kind of pointless. You got to find some middle ground where it's like, so how far is too far?
And more to the point, the problem is that if you have a wire, no matter how like loopy and crazy the shape is, it's basically the same in terms of the magnetic field. It's the same thing as if you just connected the start point to the end point with a straight wire. That's the idea of the problem.
When you're far away from it.
When you're far away, yeah.
When you're at a distant location where distant is open to interpretation, maybe.
I don't think you need to make such a strong approximation. I think the cross product integrated will lead to cancellation of the B through concentration or out of plane wire elements. Maybe Stuki is correct. So is that what you're saying initially with DL being DX, DY, DZ, and just taking R hat as 0, 1, 0?
Yeah.
Uh, and if I was good at mental math, I would instantly know what DL across R hat is, but is that actually a thing in math where you could just do the integral of DL first and then cross it with R?
I guess if R is constant, you could.
I guess we could also just do that cross product,
Yeah.
and that definitely wouldn't hurt. And we don't get a J component, right?
Right.
Zeros. K. Dx dy 0. Negative dzi. Plus dx k. And that could be integrated? I'm not crazy. I'm just gonna see what it looks like. Oh, it could be horribly wrong.
I like it.
What is the, how do we
So we're going
interpret
from,
this?
well, we're just starting at 0, 0, 0 and going to 0, 0 something. Wherever B happens to be.
We have some point very far away on the y-axis. It shouldn't depend on z though, should it?
Yeah, but it's, I don't think it's going to. So our bounds, so now if we plug in our bounds, we're starting at like 0, 0, 0 here. Oh, my pen. Keep getting booted out of Excalibur and sent back in, and then my pen gets fat again.
Oh.
And then here it would be just 0, 0. I don't know, what should we call it? L? I'm calling it L.
Oh, these should be the x components though, right?
Ah, yeah, sorry, thank you. L 0, 0.
Okay. Yeah, I forgot. I guess it should be definite.
So when we do the subtraction, the z's are both 0 anyway, so you just get something in terms of the distance from A to B along a straight line.
So we get L. Oh. Well, wait. But the current due to y should be 2 pi just r. Well, r and r
Yeah,
squared are
well,
interchangeable. I mean, maybe that's okay because that's just a constant.
well, now we want to let R be the distance to
Because this isn't the same
the
r?
point that we're, yeah, it's the same R, but we want to let R be the distance now from the x-axis to the point where we're trying to evaluate the field, right? So Yeah, sorry. Thought I had it. I don't have it. You're saying it's r squared and we want r, right? What's it supposed to look
Yeah,
like?
but
Mu
this
naught
might not be
I
the
over
2 pi r.
mu naught I over 2 pi r, so we're out by 2r.
Like, could we say that 2r squared is whatever? That seems cheesy, though. I don't think it is. What's Cook saying? Right, dl equals dx dy dz at y location xyz in point capital xyz where you want the field. R hat is that divided by magnitude. Okay, that's just an argument for treating R hat as a constant. Oh, I would get marked down if you were grading that then, because I would just be like, yeah, it's good enough. How would we possibly get one of these R's to go away? Because if we're calling R squared a constant, we'd have to somehow get it from the bounds or something. That doesn't make sense.
In this final answer we came up with, is that L supposed to be in the Z component or is it in the X component?
So I was thinking it should be in the X component because we're integrating the length of the wire, and the wire goes from 0, 0, 0 to L 0, 0. Oh wait. How maybe these I'm not plugging these bounds in right? It might that's probably not the biggest issue of the problem, but how do we
No, it's just something I noticed when I was looking at it.
Yeah, if X is equal to L in this bound, should it go with that last slide? It should be in the Z
Yeah, I think
direction,
so.
right? No, yeah, the magnetic force can't be in the X direction. Ugh.
Yeah, that makes sense. It should be in the Z direction, right? Because the current goes in the X direction and the R vector goes in the Y direction as we've set it up. So the field should be in the Z direction.
With our coordinate system, it would be the X component?
No, it's the Z. I think it looks right now, right? You changed it, now it looks right.
Well, the 4 pi r squared is still an issue, but it should be going in the Z direction somewhere. That is showing the magnetic field potential is measured against the endpoints of the wire. It should be Delamourte. I think we're not quite right. The equation that I expect to get is something like mu naught I L over 2 pi r. And we have the numerator, I think, but the denominator is wrong. Yeah, I wouldn't expect a 5th grade teacher to know Planck's law. L vector is the vector that points from A to B. Isn't L vector just the like tangential vector to wherever we're happening to integrate this along? I guess the entire L vector points from A to B, I would think, maybe? But DL.
Did we do something wrong in treating r squared as a constant and pulling it out of the integral? Because that would kind of explain why we're getting an extra r.
Why do we care about the L vector then, Cook? L vector is equal to the integral of dl vector. Why? Hey, Dr. L. Oh, hey, speaking of L's. I don't know. Q-show. Yeah, this right here is our current result that looks incorrect. Well, the denominator looks incorrect. I think I like the numerator in that vector on the end of it. You are almost certainly not going to get to learn Planck's law in middle school. I mean, I don't know what Planck's law is, but I assume it's like a university thing. So the only issue that I have with the answer that we've gotten is I expect to get 2 pi r for the denominator, not 4 pi r squared.
When you get mu naught IL over 2 pi r as the magnetic field from a wire, did we have to assume the wire was like infinitely long to come up with that?
Probably. So maybe that doesn't hold?
Could that be something to do with it? Because we're not assuming A and B are infinitely far apart, are we?
It's true.
Yeah, the length of the wires is definitely neglected. It looks like. When they get this. That could be it.
Actually, that's that equation 612 there. It says the B1 is mu naught I over 2 pi r, but we don't have any L on top. So
Right.
that's okay. So if we did mu naught IL over 2 pi r, we're dimensionally wrong, aren't we? So maybe
Why
we
was I
don't
putting
need
the
that
L
L.
there? Maybe I was just getting mixed up with what we were doing in the last problems.
I mean, that L should be there.
uh,
Because the X has to integrate somewhere.
oh yeah, so maybe like the L should be there in our answer, but that might fix our dimension issue. if we're not expecting an L in the, or like, if we only want one distance measurement in the denominator, this might be okay.
Oh,
Then?
so if L equals 2R, we're gold. So all we got to do is measure the field at a distance twice the length from A to B away from it. Right?
I guess.
I'm not really sure what to make of this, but
Dr. Cook says our answer is the same result you would get by writing down BO sub R for a straight wire. Oh, maybe we're good.
Maybe. I think it's Dr. Cook is raising a good point where treating R in our hat as constant means we're just making the wire straight already. But
yeah.
I don't know.
Oh, comparing to an infinite wire is the wrong approach.
Really far away from an infinite wire. Okay. So is that why we were talking about the L vector before, where the L vector just points in a straight line? Because those vertical components of the DL vectors all cancel. Right, be able to write for a straight finite wire, you'll get the exact same expression. Okay. I believe it without having to like go through the pain of seeing it, but that's basically what we just did, I think.
Yeah.
I see that we're basically at the 2-hour mark. Should we just check the answer here?
Do
Yeah.
it.
Okay. What's this number? That's not right. 8. Field from a loopy wire. Okay. Bios of our law gives the field contribution from a piece DL of the wires DB. What's that? Okay, they do make that approximation.
Nice thinking, Stooky. Nice work.
Integrate over the entire wire, take these quantities outside the integral. Oh, you can integrate before doing the cross product. That feels so weird to me. I feel like that should be an issue. I guess not.
It does feel weird.
I guess we did it right. And we just actually did L cross R.
That's
I think we did it right.
Dr. Cook is calling out Morin for a weak solution, though. I feel like we need a cage fight. Okay. As this feels a little unsatisfying, to be honest. I thought there was going to be something more. But, oh well.
That was good. That was a good one to finish on.
Yeah.
Yeah.
So I guess, should we plan for like the default kind of like 2 more meetings on chapter 6 and moving on after that, or how are you feeling about this chapter?
Good to me.
Okay.
Yeah, sounds good to me.
Awesome. Well, hopefully see you 2 next week.
Yeah.
I might
Thanks for
be
being here.
2 weeks, but
No worries.
I'll see you soon.
All right. Well, whenever next time is.
Yeah.
All right.
All
Bye,
right.
guys.
Thanks, Don.
Take care. Thanks for hosting.
Thank you.
Yep. See ya.
Okay. Awesome. Some more fun problems today. Del Morte, thank you for the follow. So yes, sorry I wasn't able to keep up with the chat as much as I normally would, but as for these little physics streams, I try to prioritize the discussion that we're having on the call there. Thank you for the follow, Delamorte. So yeah, these Saturday streams are 2 hours of this physics reading that you just saw, and then I'm going to switch into math help, which is what I'm going to do right now. Let me get some music going. We'll do the playlist that I've just kind of always been using. I need to take a second to switch my stream title and category. But yeah, welcome into all the new faces who have been here today. I do dual stream to Twitch and YouTube, so if you hear me talking to someone who's not there in chat, that's why. This playlist is, oh, it's only 5.5 hours of music. I feel like I've memorized half the songs though. It's not bad music though. This song I recognize. Chapter 6 is much gentler than 5. Well, that's true. We don't have a million constants to keep track of. Where are my YouTube thumbnails? There they are. They're naturally in my Twitch folder. Okay, YouTube info is updated. Twitch info. Answering math homework questions and studying. Category math. Okay. I can come back to this scene. You include a follow. You would also include a follow and a full solution. Oh, I haven't read the above thing. I feel like I'm forgetting something. Oh, I should let's quickly post the notes that we just took here to Discord. You'll meet 2 more times on chapter 6, then our first meeting on chapter 7 will be on, all right, October 12th, October 19th, October 26th will be chapter 7. Wait, did I say, oh crap, okay, never mind, 26, okay. Nice. Solve the Riemann hypothesis. You first. Enough to pass an exam, so not really. It feels bad. Sorry. There's something about that. It's really like, fuck my professors. I only know enough to pass an exam, so I don't really know it. Intro physics textbooks called the magnetic field a vector. In reality, it is a 2 form. It comes up in physics because E reflects if U reflects physical space, but B does not. This is called B a pseudo vector for this reason, but in reality, it is a 2 form. It's like towards the end of this chapter, I don't know if it's the same thing that you're talking about there, Cook, but when they're talking about how transforming E and B fields in different frames, you can think of the different components of them as components of the field, but it's not actually a vector, it's a tensor. And they just kind of like mention that without going into the details, but I assume that's what you're talking about? My brother's an electrician, so I have some idea of this stuff. I dropped out of physics and some of the advanced when I was in high school because I felt no one explained to me correctly. Yeah, Delamorte, hated physics until I started reading this book. Um, but this book is using a lot of math that I'm actually really interested in, and it's got me super enthusiastic about trying to learn it. That's also like that you're like trying to switch more into electronic engineering, you said before, right? So you're a baker right now, which I think is also super cool. It's false modesty. What is true is I never really grasped the yoga for converting problems about tangent bundles into multivariable calculus. Oh, tangent bundle sounds interesting. Never good at solving actual problems, even if I know how some pieces fit together. Okay. The upshot is that you should think of magnetic field B as a two form, i.e. an oriented plane. The oriented plane corresponds to the circular planar motion. Does the B field induce circular motion on a moving point charge? I thought it repels or attracts. Kind of distinct plane. The Faraday tensor is also two form. I don't know. Math letters. Hey, Country Tyler. Sochi, feel free to put your problem there in chat. You really got to do more math. I've been slacking. Yanis, I think you have to do some physics. No. The paint queued up. Okay. Okay, so Cook, about that the gravity book. If that's something that you want to do, I would absolutely be enthusiastic about participating in it and like acting as like a home base for like the stream or whatever of it. But as far as I'm concerned, it's like up to you how you want to run it, or if you would rather do it through your like stream. I don't know if you're even able to right now, but like however you want to run it, I'd be good with participating in it. Charged particles get excited and spiral when they move through magnetic field. Really? Wait. My my intuition for everything electromagnetic is 0. I know that the B field, like it goes in a spiral, but I thought the actual effect on the particle was attraction or repelling. We can hop on chat right now if you want. If you want to just like pop into the waiting room, voice chat or something, and I'll drag you. But I don't care either way if you want to talk about publicly or privately. See that B is not a vector. A cross product appears and how B acts on moving charges. Cross products are cursed, only really dependent on 3 and 7. I didn't know the 7 dimensions thing. But yeah, that's the Lorentz force right there, where the total force that the charged particle experiences is the charge times the electric field plus the charge times the velocity. I always get mixed up which velocity exactly is, but the velocity of like the current crossed with the B field. You do something exact, yeah. See, like I know like it goes in a spiral like that, but identify a vector with a plane it's normal to, right? You would training B as a vector in 3D. Now it's a two-form oriented plane perpendicular. to that vector. That part I never heard of a two form before. An oriented plane, I guess, kind of makes sense, but like I don't imagine I'm thinking about it the right way. And why would we work? It's probably K forms. I'm sure there's a good reason for it, but why do we need more than 3 dimensions? But then I just remembered that, you know, I think reality has more than 3 dimensions, or else it could. Ions, protons, electrons, science. Yeah, Cook, if you want to hop in voice, just feel free to hop in any of the channels in my Discord and I'll like drag you. I don't think there's any pending like math questions anyway, so. Lorentz force is a contraction between the 4 velocity vector and a 2 form. So it's another vector of the 4 force. Okay. Reality is 12 dimensional, maybe more if it decides it needs it. As far as I know, they've gone up to like 27 or something crazy like that. I don't actually know. Bill and Joe, the electromagnetic employees. I'm still struggling with like, which way do we consider this V to be pointing, with the electrons or with the positive current? And I'm trying to make some kind of rule where like, if I was looking right at this wire, would B go clockwise or counterclockwise? In the waiting room? Okay. I'll figure it out later. Hey.
Hey, what's going on, man? How you doing?
I'm doing good. How about you?
I'm okay. I wish I was streaming more. I feel kind of bummed out about that, but
I wish you were able to, yeah.
yeah. Oh, shoot. Uh, sorry, getting a phone call. Okay, sorry, I don't know how to turn this on. Yeah, I'll probably have to go quick to return that phone call. You still there?
Oh, yeah.
Hello?
I'm here.
Oh, okay.
Can you hear me? Okay.
Yeah, yeah, I can hear you. Sorry, I got a phone call and it went through the computer. Anyway, yeah, okay, so right, so yeah, about this gravity thing, I'm pretty open-minded. But there are a couple things. One is my internet, which as you said, it's unclear how relevant that would be depending on what we want to do. But I'm trying to get that resolved. I just need to get a Wi-Fi extender out here. That could take another week or two. But we could go through the. Do you have the PDF for Hartle? We could go through that and talk about topics.
Oh,
maybe.
I don't. I should have gone and grabbed it. I don't. That's one of those you sent to me like a.
I can DM it to you.
Yeah, if you could.
Yeah, one moment. I put a list of chapters in them.
Right.
Yeah. Okay. I think I just DM'd you the book, you and Finbox. Yeah, nothing about timing. You mentioned January, which made sense to me. I do think you guys should finish E&M, and also I thought your idea of mechanics review was a good idea.
Okay.
But yeah, what was your anticipated end date for E&M again?
I'm thinking I don't have an exact date, but this
Well, you
we've been doing
timed it
3
out.
weeks per chapter. And we just started chapter 6, so chapter 7. I think we're definitely going to be done in like by the end of December.
Okay. Yeah, I think that's a good goal for you guys too. Like even if you start falling behind, it might be worthwhile to try to like do 2 sessions a week or just to be on the school schedule or whatever.
Oh yeah,
I
we
don't know if
could
that matters to you.
think about that.
Yeah. Okay. So yeah, the relevant point here is I am applying for jobs now, some of which do begin for the spring semester, which is like January, February. So maybe I shouldn't commit myself to lectures, but I mean, there are a few things I would like to show people about relativity I've thought about that aren't in Hartle. So I mean, like just quick calculations or kind of what Zach does, I think might be a good structure.
Okay. So yeah, I was offering to like potentially like put this thing on pause because I figured like you might be busy early next year or so. But if it would be better to try and do like the mechanics review and get through this, then I don't know. I'm happy to try and work around your schedule as much as possible here.
Well,
yeah.
if you wanted to, I don't know if you would be up for this, but you could do them simultaneously. I mean, E&M is not a prerequisite for Hartle's book.
I would take that on. So
Yeah, I'd be happy to do that too. How about this then?
I just want to make it convenient for you, I guess.
Yeah. Yeah. I mean, if it's before, I mean, honestly, I might not get a job for January, so this could all be a moot point. But I mean, for now, yeah, it's no inconvenience at all. In fact, I want to talk about relativity. I think it'd be a lot of fun.
Okay.
But I think, given what we've talked about just now, maybe a good proposal would be, you guys keep going with E&M. I'll take the next week or two, try to get this internet fixed. And in the meantime, maybe you guys could review mechanics for the next 2 weeks or 3 weeks. Because you said you want to speed run it, right? And I think more.
So I can go through that. Yeah, I think I pulled that. Maybe.
Yeah, that's a very problem focused book, and it sounds like you guys already know most of the actual theory. So I think you could kind of speed run a problem book like that.
Yeah, I think Venlox is already like pretty solid on this. More like me, I haven't done mechanics in a very long time, so.
Yeah, I do think that probably will be important for Hartle. So it would be good to spend some time in the short term going over that blue book.
Oh, did I get?
Especially.
Oh shit! I should get the blue book. I think I just got the red book. But yeah, I can work
it's
on
called
that.
Problems and Solutions in Mechanics by Mechanic, and especially the gravity chapter towards the end. I mean, it's good to like be really have your Newtonian gravity nailed down before you go to Einstein.
Yeah.
Yeah. Okay. Do you want to pull up the PDF for this?
I think I got it right here.
Oh, I'm not running the. Sorry, I had it paused. Yeah. Okay. So yeah, let's go to the table of contents.
Okay.
And there's something important here I wanted to talk to you about. Yeah, this is like the Indian version. So, oh wait, is there no? Oh, it's cut off. Can you open the PDF table of contents on the left? It'll show more chapters.
There. Oh, that's weird. Okay.
Yeah, I noticed that too with this PDF. You can probably find a better PDF. Like this is the international edition or something. Yeah. Okay. So I'll pull up my copy here. Yeah. Okay. So I suggested doing chapters 1 through 9. Like I think those are essential. And that's like a good intro to like just the very basics of GR.
Okay.
And then 10 and 11, I think I'm a little less interested in because they're applications of relativity. Although you guys might be very interested in that. I don't know. I think the next chapter I suggested was 15. So that's when you take so chapter 9 studies like just a straight up spherical mass, which is the same as a black hole if it's compact enough. And chapter 15 is if that black hole or spherical mass starts rotating. And that's actually extremely interesting. So I would suggest 15 for sure. And then probably 16 too, because gravitational waves were discovered for the very first time only in 2015. So that's going to be a major point of our lives, I think. Over the next 30 years, you're going to hear a lot of stuff about gravitational wave astronomy. It's basically like we got a second set of eyes for the universe, where previously we could only see things that emitted light, but now we can see things that emit both either light or gravitational waves. So it's like humanity just acquired a whole new set of eyes only in 2015.
Wow.
So I think chapter 16 is essentially a must-do topic since 2015. And then I think I would suggest chapter 18, because that's about the expansion of the universe, Big Bang, and all that. And I feel like that's
cool.
Most people are pretty excited about that. Yeah. Okay, yeah, and then that's where I suggested ending, and I think that's where an undergrad course on this subject would probably end, at least at most universities. But there's a part 3 of this, starting with chapter 20. And now this is a baby introduction to differential geometry, and then writing down the Einstein field equation, which is the gravitational version of Maxwell's equations. But to really understand it requires some differential geometry, which Hartle gives the basics of. But if you just want a first introduction to GR, I mean, you could stop at chapter 18, like we said, and I think you'd understand the physical content. But I know you're into math, so I assume you probably want to learn differential geometry before you die. So
I know very little about it. I'm open to learning something about it.
I think the 30,000. Well, maybe Stucky could say more. He's a proper mathematician, it sounds like. But the way I think of differential geometry, the high level way to see it, it's like doing calculus on a potato. That's how I would describe it.
So just
how do you do calculus?
Irregular shape, do anything?
Yes,
with it?
but not Yes,
Okay.
but not arbitrarily irregular. It has to. If you zoom in close enough, it has to look like r to the n, or said more simply, in this case, for a 2D surface, it has to look locally like a plane. And if you imagine zooming in on a potato, if you keep zooming in on a potato, it'll eventually look flat.
Okay, Gauss Law's the same constraint. I remember the book talking about for E&M. It sounds like it does.
For the surface?
Yeah, the surface. Yeah.
Oh,
Maybe it's a different topic that just.
Well, I think in that case, it's a little bit more forgiving because, for example, let's think about this. Well, for Gauss's law of the surface, you can use a cube, right? That's a perfectly valid Gaussian surface, and that has kinks galore on the sides. I don't know.
I might be misremembering how they phrased it.
This might be a good question for Stucky. I don't know if the surface of a cube is a manifold. I mean, certainly it's not a differential manifold. It might be a topological manifold. In fact, that probably is true.
Anyway, that's not the point, I guess.
Yeah. So this is the high-level picture. Is differential geometry lets you do calculus on curved surfaces, and GR, you're talking about curved 4-dimensional spaces.
Hey, SPQ. So yeah, I think this sounds really cool to try and study, and I'll absolutely try and get back up to speed on my mechanics in that 1 to 2 weeks or however long you would want before you start it.
Yeah. I made a phone call to the computer guy today, but it's Saturday. He said he'd come out last week on Monday, but I live in a small town right now, and people aren't very good about a couple things I've noticed. So I'm trying to get him out here. But yeah, hopefully it won't be much longer. But even if even if I get it back online in a week, I think that probably won't be enough time for you to properly review.
Probably not.
Mechanics. Yeah.
And think about it now, I do have a 2-week time period in November where I'm gonna be out.
Oh,
that actually does kind of throw a wrench in that. The 7th through the 20th or so.
Okay, maybe after you get back would be a good time to start then.
Yeah, I forgot about that. But that would only be like a month plus a bit, depending on how your schedule looks for the new year.
Yeah. Well, I don't know yeah, okay. Another relevant variable would be how often you'd want to meet. Would you want to do it just once a week, like E&M?
Uh, so I've been trying to keep it just like for the sake of the E&M. I've just been trying to keep it easy because it's all like self reading. But I think if other people are interested, like since we'd have you as more of a guide here, we could probably move a bit faster.
Yeah, okay.
If you want to
So
do it 2 times a week.
if I don't have a job, which is true at least until January, I'm happy to do, and once I get my internet fixed, I'm happy to do essentially as much as you want to do per week, like 3 or 4 times a week if you wanted to. But if I got a job in January and we were still going, I could probably still commit to once a week. I don't know what I'll be doing, but I don't see why I couldn't do a couple hours on a weekend or something.
Okay, I mean, I guess we can see how things shape up over the next like few weeks too. Like, it doesn't like we ever have to commit to anything, but um, you definitely have enthusiastic support from me, and I'm willing to like, go pretty hard on this. So,
Dude, I love that. I have so much enthusiasm for relativity. It's like I'm bursting at the seams. So I don't think it's as much of a favorite. um, Also, yeah, I think I mentioned when I first came on Twitch, I want to write this relativity book, and I've been slacking on it. So I think
oh,
it would be good for me to try out some ideas because like I, um, I have an approach to special relativity in mind, which is known in the literature, but for some reason doesn't appear in textbooks. And I think I can bring it to the undergrad level, but you and Finvox and whoever else wants to participate would be good guinea pigs for that.
yeah, I'd be happy to be the guinea pig.
Um, okay. Okay, how about this then? So November 20th. Hmm. You want to just aim for starting after that date?
Sure.
Okay. Okay, yeah, that'll give you plenty of time. In fact, so November 7th. I mean, is there any way you could finish E&M before then, or is that just unrealistic?
Uh,
Because that would be a good
individually,
like division.
I could
That'd
just
be a
read
good
through the
division, right?
chapters and not worry about the problems as much. I wouldn't want the actual like ask like Stuki as well and then let's like try and get through all that. But I definitely could commit to reading like chapters 7 and 9 of the E&M book that we were planning to before
Or how
then.
about this? Maybe ending like after November 20th. Then that would give more time. But then I guess you guys would be separate. Or how much like
The 7th to the 20th, like, is it just you won't be on Twitch, but you could study in your free time, or you're just like gonna put this all
I'm gonna be on
behind you?
vacation. I mean, I might have some downtime where I can study, but I don't know.
yeah.
Um,
Okay. Well,
Seneca said, "He who worries before it's necessary worries more than necessary." So maybe this is sufficient. How about let's just how you if you could add on the more in blue book to your streams at least once a week and try to get like speed through that before November 20th. I think that would be a good idea. Then we can
yeah,
go
that
from there.
I can definitely do because I can just do it during like the downtime whenever I have time. So
Okay, and then then I think it's probably not an issue if the last bit of E&M overlaps while you're doing right because you were okay with doing them both, right?
yeah,
Yeah. Okay. Yeah. So let's not like push you guys to finish E&M super fast, but you definitely should try to do the mechanics review super fast.
okay. Sounds good then.
All right. Is there anything else to discuss?
I don't think
Do you have the
so.
blue book? Let's see if I got it.
I thought I did, but I apparently don't. So if you have it offhand, that'd be nice.
Let me check. I can't find it either. It's kind of a newer book. Oh wait, no, do I actually, was that it? Oh, I have the first chapter from, I don't have the whole book.
I can try
Yeah, I can
taking a look
find it.
after the stream, or if you find it, then yeah.
Yeah, I'll hop off here and it'll take me a few minutes. I can find it.
Okay.
Yeah, okay. Let's stay in touch. I think this is a really good idea for both you and me. So this will be a lot of fun.
Awesome. Yeah, that sounds amazing. So thank you for putting that
Nice.
idea forward.
Well, I'm just appreciative that you're interested in relativity because I think at this stage in physics education, a lot of people, and I think this is partly due to the way the physics curriculum at most universities is set up, and so maybe you're not feeling that negative influence. But at university, a lot of people at this level, they just want to jump straight to quantum mechanics.
Oh.
So the result is that at American universities, general relativity, or I'd say even relativity wholesale, is not taught very well, especially to undergraduates. So I did my master's degree in Canada, and it was like an international master's. There's 30 students, and I was only one of 2 from the U.S. And it was very apparent how much better the Europeans knew relativity. So that's been kind of an issue for me trying to teach relativity or sell myself as teaching relativity at universities because it's not really seen as useful for undergrads. But I don't understand why. Like once you learn it, it's just beautiful, and you talk about the beginning of the universe and the end of the universe, and I don't know what's not time travel, what's not to love,
Yeah. Yeah, my reaction to physics in college was not liking it because I feel my professors maybe or choose parts of it that I was interested in. But yeah, getting the taste of special relativity makes me want to learn a lot more about it. So,
what physics classes did you take in college?
I did a semester of mechanics, a semester of E&M, but there's no multivariable calculus involved, just like kind of basic stuff, and I just kind of felt tedious, I guess, or not helpful.
What textbooks did you guys use?
Oh,
Like Walker,
I don't
Crane,
remember.
kind of stuff? Oh.
Probably some Pearson thing or something. I remember my school used a lot.
Okay, well, I'm sorry he spoiled it for you, but or he or she. But
I'm here
yeah,
now.
no, I've noticed that too. I think physics is really not taught very well at most places. I don't know.
Yeah.
Okay.
Yeah.
Sorry. Go ahead.
No, I'm saying I don't know. I guess for me, I'm more impressed by getting to use the hard math, and they probably want to avoid the hard math. So that might be unfair for me, but.
No, I mean that's a good point. I mean, I think it's another reason I think relativity doesn't penetrate undergrad as much because it usually the typical way it's taught requires a lot of mathematics, like introductory differential geometry. But this Hartle book is very unique, and somehow he manages to teach just the very minimum differential geometry to get the idea of GR, and it's very impressive. So, yeah, I think you can teach quantum mechanics with a lot less math background. That's probably another reason why this happens.
Okay. Awesome. Well.
Yeah, let me grab that book.
Oh yeah.
Yeah. Okay. Let's keep talking.
Yeah,
right.
Absolutely.
Okay. Later, Don.
All right. See you. All right, dude. I'm kind of psyched. This is a really cool thing that we might get to do here. So yeah, that was Dr. Cook, who has streamed and will hopefully be able to return to streaming soon, as you all heard. Shivam, thank you for the follow. In basketball for YouTube, I promise I'm not ignoring you. I'm just juggling multiple balls here. Okay, so sorry, Ben. I saw what you put there. I'm sorry that I didn't address it, but your granddad wrote a physics book. Physics of continuous matter. It's kind of sick. Niels Bohr Institute. Ooh, I recognize that name. The Lorentz group is the group of all Lorentz transformation Minkowski spacetime. Ooh, I don't know what that is. Oh, and country title, yeah. Dr. Cook is awesome. Hey, Shivam. Oh yeah, you mentioned that. I remember you talking about that. Neat. So it's probably going to take a minute to download. If I do it now, but we'll take a look. Del Morte, so what is it are you studying? Well, you kind of just heard it evolve just now. Table of contents, yeah. You had a math test today, Shivam? Oh, I hope it went well. You worked at Kern, Brookhaven National Laboratory, and some other places? Ooh, wow. That's awesome, Ben. Oh, this book. Sorry. I'll slowly scroll through it. Archimedes principle. I assume that's different from the math one. So yeah, Delamorte, what is it am I studying? I have been studying for the last like maybe 6 months or so as part of that reading group, Electricity and Magnetism, and I've found I'm really enthusiastic about physics as it turns out. So you just heard it evolve into me trying to speedrun, remembering how to learn mechanics, and then Dr. Cook kind of hosting this potential, like, I guess I'll put quote unquote class because we don't know how it's going to be structured, but on general relativity. Music, you can understand a single thing. Let's see what's the wow, this is a long book. This is a bunch of different topics. Space on twist, you need to transform the vector equations to use Lorentz. Oh, okay. Term viscosity is especially helpful. This feels like chemistry so far. It's probably helpful to know some though. Mean free path? Talking about that for like electrons conducting, but I guess that makes sense. It's also in other areas too. Dementia hit him. Oh dang, dementia freaking sucks. Shivam, Brianna, we're kind of bouncing around between a couple of different topics in physics. Basil put a question for me in the YouTube chat a while ago, and I've been neglecting them. Just remember when Stom pulled up. Yeah. I'll put the link there in chat again in case I got lost in the shuffle and someone wants to like look back through it again. So Basil from the YouTube chat is asking this that I'm pasting over to Twitch. I haven't even read the question yet, but why isn't Desmos loading? Save it, have others use it. That's always awesome to see. I'm running to my old high school teachers and showing to them that's the only thing they knew. Oh yeah. Studying grad level textbooks, so I'm continuing physics. This book was some undergrad textbook. I turned to when I got confused. Oh, nice. I should run a speed test. It's apparently terrible right now. I don't know, like my internet. Ugh. Is it gonna say? I feel like it's gonna say your location. I don't really care that much about it, but let me see what it's gonna look like if I do this. Speedtest.net. Yeah, it's saying where I am, so I won't show the actual. It's saying more or less where I am, but so I'm not gonna show the actual test, but let's see what it is. Satyam, yeah, I love calculus. So I have fiber internet. It feels like it just randomly goes slow sometimes, though. I don't really know why. Maybe I need to restart my router more often. Like for certain things, like sometimes like Discord or certain websites, it just kind of takes forever to load. My download is 365 right now, though. The upload is 350 and climbing. 352. Like I have good internet, and I'm connected by Ethernet, so I don't really know why that happens. Now Desmos is loading fine. It might be my browser, to be honest. I just have some extension that's not behaving. Wait, what? Or maybe this person doesn't mean me to actually like graph this in Desmos, just to paste the question into Desmos. Never mind. Dang. Get it while it's hot, boys. Gotta get back. All right. See you, Cook. Thanks again for talking. Oh wow, that's a small file size. It's only 2 megabytes. It's not cut off, is it? It goes out to page 253. No, it's just a small book. Okay. Actually, before I forget, let me download this other book too. Yeah. So it's it's that's a good source. I'm being hesitant because Twitch has, you know, certain things that, you know, maybe you should or shouldn't talk about, but if you don't find a PDF of a book, that's the place. And there are different mirrors of the site you sometimes have to go to, but that's the idea. Okay, thanks for being patient, Basil. N equals 100. Okay. So why is this equal to 5,000? While this is equal to 50/50? Like if the principal integral of a function is the infinitely priced sum of the values of a function from point A to B, when we expect the value to be higher than 50/50. All right, see you, Ben. Thank you for sharing that book. Yeah, I recognize that as like Gauss's sum, Basil, right? So why would these be the same? Because yeah, this is some of the first 100 numbers. The first 100, I guess, natural numbers. And this is the integral from 0 to 100 of f of x. You expect the integral's value to be higher than the integer sum. I think we need to think about the Riemann sum and what if we're getting a left or right hand Riemann sum. That's my assumption. So the question is basically, why is the number from 0 to 100 of x dx less than 100 times 100 plus 1 over 2? And I think we gotta think about that as a Riemann sum. That's my assumption, at least. Course I started with mathematical modeling for computing, so discrete math is everything in that. Ooh, nice. Modeling is awesome. Hey, Sai. And so if we're summing, this is basically Riemann sum with width 1. Yeah, exactly. So that's the same thing as sigma. Oops, that's not sigma. N equals 1 to 100 of n. Same thing. And so I think the reason why we get this is that the first rectangle we make here the first rectangle we make, I think it's going to start at x equals 1 and go up above and make this thing here. So it's going to be it's actually a square, width 1, height 1. In the next one we go one more out, and then we go up to height 2, which coincides with y equals x at x equals 2. And then we come back over and go here. I think that's what's happening geometrically for why this thing should be an overestimate. And you could theoretically get the area of these small triangles here, because they should all be overestimating by the same amount. And you should get 50. Boolean logic is drilled into. Oh, I bet. So each of these right triangles that we're getting in the upper part has, hey Smiler, width 1 and height 1. Suna, hey. And the area of this is 1/2 base times height, so just 1/2. How's your stream, Suna? I hope it went well. Yeah, there's a triangle 0.5. Perfect. And so here we have 100 of these triangles though. So we get 100 times 1/2 is 50, and that's the error exactly. Since we said this thing was 5,000 and this thing is 50/50. It's going good. How about you? And so let me go back to what you were originally saying in your question. Is the principal integral of a function? Is the infinitely precise sum of values of the function? That. I guess, so maybe to try to address your original question is, just because you have a sum that more or less represents the integral, it doesn't mean that it's an underestimate. I think is maybe the heart of your question. It could be an overestimate like what we're seeing here. You just kind of have to look at the individual situation and figure out if you're over or underestimating. So I hope that you're doing well too. Suna, I haven't been able to tune into your stream much recently, so I'm sorry about that. But I saw your title, at least, was something about like trying to recover your computer's memory. I hope it's not too messed up. So no, Basil, do you think that addresses your question there? Or am I misunderstanding? Maybe you're asking about something else. Like, we actually could also look at the Riemann sum. I think if you had, or if you looked at the sum of n equals Would it be 1 to 99? You might get the underestimate. It might be 2 to 100. I can't tell. It might be 1 to 99, but there should be an equivalent sum you can make for a similar looking underestimate. Would it be accurate to find the principal integral as the precise sum of the function's values from a to b? So the term principal integral I'm not familiar with. I don't know if you mean something specific with that I haven't heard of before. But for like we normally define an integral as basically this sum with rectangles made infinitely narrow or arbitrarily narrow, and that becomes a perfect approximation. And I'm sorry if this isn't the thing that you're asking about. I feel like it is, but so it's possible I'm wrong. What's the I think from I equals 1. Oh man, I don't remember this definition offhand. Maybe I equals 1 to infinity of the width of these rectangles times the height of the function at each thing. When you have infinitely many of these rectangles happening. So this exact formulation on the right side might not be the exact right thing. I think you could do yeah, if that was the case. The integral from point A to B would be encompassing the sum of the values integers and additional values yielding a higher number. The integral from A to B would be encompassing the sum of the values integers, n plus 1 over 2, and additional values, yielding a higher number. No, because if I'm understanding you right, because the idea is that as we make these rectangles more and more narrow, let me come over here. Oh, terrible. Terrible. Let's use the line tool. There we go. That's y equals x. As we make the rectangles more and more narrow, the over-approximation error gets smaller. So like, you're right, we are including the actual like values right there, but the important thing to understand is like the difference is coming from those little triangles there, and the narrower our rectangles are, the less that error is. I think that's what you're asking, Basil, but I'm sorry if I'm not understanding it. Yeah, Delmore, I'm not completely confident what I'm doing either, that I'm actually getting to the heart of the question here. But just for anyone who's wondering, I'm talking to Basil over in the YouTube chat right now. So I'm sorry, I wish I could display the YouTube chat up there, but Twitch doesn't allow it. I just realized, I think if I just multiplied the weight force by 3 in that second problem we did, that would have gotten the right answer without having to go through all these torques. Well, definitely our final answer wasn't off by a factor of 3, though. Would it get canceled somewhere or something? We're off by about like 2, a little less than twice. It's the next error. They should invent alcohol that doesn't end too early. Like, serving alcohol? What do you mean? Oh, root 3. That makes... Okay. Interesting. Oh, yeah, because you would square it because it's I squared. Okay. Yeah, that's fair. This is like DA conversion. I think I've heard of DA conversion. So, Basil, I haven't seen anything for you. Let me know if I'm sorry if I'm not understanding you quite right, but just because we're including like these points here along the line doesn't mean we're actually increasing. Oh, there you just said something. Do you know anything about taking the square root of a matrix square? I think I've done it before. I don't remember how exactly it works. I could try and look into it. It almost certainly has to be invertible, right? Maybe not, I don't know. In this case, the sum of the integers was 50 if all the integers values 5,000. Is the sum of the integers series a function? Is the sum of the integers series of a function from point A to B always larger than the integral of that function? No, I think you could devise a series, a sum of integers that underestimates this. I think you could do, I remember time getting the exact series in my head right now, but there's, oops. You could do, well, it would be called like a left, basically that's about the difference between a left and a right hand Riemann sum. If you want something to like Google and look into more. But I think you could find something like this, like maybe n equals 1 to 99, that would represent an underestimate. So your first one would be 0, and then you would come up to here and go over, and so on like this. And now you get all these triangles inside that are showing how we're going, like, where we're underestimating. So you can get an over or an underestimate. Digital analog conversion. Oh, okay. Something PD, something here equal P inverse, where D is the diagonal eigenvalues. Oh, do you need the eigenvalue decomposition to get the square root of a matrix? The Wikipedia link was purple, so I had definitely Googled this before. Why do I ever click on Wikipedia though? You get really annoyed system equations? Oh, okay. Oh, they're saying to diagonalize it here too. No worries, Basil. Thank you for the question, and thank you for your patience. Oh. Oh, what the heck? Okay. This seems like what you want. I'll drop the link there in chat and we can like talk about it too, but you also want to talk about diagonalization in general. So I don't know very much about it. What I do know is if you have a matrix A, B, C, D, and you know its eigenvalues are lambda 1, lambda 2, and the eigenvectors are... Did I make my psi the right way? I don't know. Psi 1 and psi 2. I think I made it backwards. Oh god, I hate this letter, dude. I think that's right. I think the second one is closer to being correct. It's the worst one. Just use V. That's my... Yeah, you know, that's a good idea. V1, V2. I know that you can decompose this ABCD matrix. If you look... I need to study it more, but I kind of feel similarly. You can decompose this into... you can diagonalize it. So... I guess importantly, this is... these are the components of V, so maybe I'll say... maybe V1 is V1x and V1y. And similar for V2. So you basically take your eigenvectors and put them into a 2x2 matrix, multiply that by a diagonal matrix with your eigenvalues. And so diagonal matrix means that only this diagonal has entries, everything else is 0. And then you have the same eigenvector matrix, but inverted. And this abomination here is exactly equal to your original matrix. Now, why you want to do this, I don't know exactly why. Apparently to look to get the square root of a matrix. But as far as I know, that's the idea behind what the diagonalization is. It's just this part. Yeah. I don't know what the proof is either. So you wouldn't get a very good answer from me. I just know the pattern of what you do. And so I think the idea is that the square root of this thing is apparently obvious. And so I'll work through it backwards, which is I'm going to start with what they say the square root is and square it. They're saying the square root is nearly the exact same thing, but you only square root the eigen values. Because if you take this whole thing that we're saying the square is the square root and square it, what you're going to get... I'm going to do some copy pasting here so I don't have to rewrite all this garbage. You get this twice, of course. But while matrix multiplication isn't commutative, it is associative. So we can choose to do this multiplication first, and that's an inverse times the original matrix, which is just the identity. So we can just get rid of that. And so the idea is that this thing is collapsing to v1x, v2x, v1y, v2y. Root lambda 1, 0, 0, root lambda 2, root lambda 1, 0, 0, root lambda 2. And the right side here. So I just did that matrix there, and then we need this inverse one that I'm going to copy paste. And then you can do these two multiply by each other on the inside. And that matrix multiplication is relatively easy because you just get lambda 1 and lambda 2. Right? Yeah. Good old mental math verification. So we do indeed get our original matrix back out from this proposed square root that we magically guessed, basically. And so if you want to find, I guess if you want to find the square root of a matrix, you find its diagonalization, you square root your eigenvalues, and then you multiply everything back inside with each other. Yeah. No worries. If we're living in the matrix, is there any good way to find the eigenvalues? True megalomorph. Trying to find a logarithm for matrices. Oh. So the definition of L on X, when as h goes to 0, of x to the h minus 1 over h. Really? That looks like a derivative. To achieve h nearing 0, we can just let h equals 1/2 to the n square root n times. So if I derivative a to the x. Oh, interesting. Okay. And so you're saying a change of variables here with h equals 1/2 to the n? With L'Hopital's? Oh, okay. Yeah, so if h goes to 0, isn't n going to negative infinity? Oh, I see. Yeah, because it's 1/2. I see. Of the doi. Yeah, you're right. X to the 1/2 to the n. So that's like, okay, that's where your square roots are coming from. Is that changing the 1 to I? Or L? Maybe? I'm not sure what the point of that is. The exponentiating that works through the power series. Can't minus a scalar from matrix. Oh, I see. Like matrix I. Okay, I thought it was just some arbitrary scalar constant. You can use the Taylor series of ln1 plus x. As the eigenvalues of x be less than 1. If you have bigger eigenvalues, you want to restrict to each of your eigenspaces factor out a constant, take the log of the block. Boring. If you're not doing it the hard and arbitrary way, then are you really doing math? Okay, yeah, that's what syntax is saying. I guess I don't see. Are we saying that X is a matrix here? Oh, that's it. So you're trying to find a log for matrices, and that's where you're asking about the square root of a matrix. Okay, it's all connecting now. So yeah, that's why the one would become I. Hmm. Yeah, I don't know what you do with that, but that is neat. Also, my H looks just like my N. Gonna hate you after this. Yeah, dude. I'm sure your teacher hated you long before this. Ugh. Syntax, I feel like you're like your mission in life is to do math at any cost, which I appreciate. Did this get downloaded for me? I'm looking for my files. 1 second. Yeah, I got it downloaded. Okay. And then I also got gravity. Okay, good. Okay, nice. I don't think there's another math question that's waiting for me to get to. Let me make sure I'm not missing them in my Discord though. Okay, no, it's been pretty slow in there, at least for questions that I can actually do. That differential equation thing you showed me, syntax, was kind of fucked. I can't believe that's a real thing. You cooked one of my calc teachers on the limit problem. The book's answer was clearly wrong. I asked her about it. She tried to defend it. So we looked at the solutions book thing. It's with teachers and it turned out it was correct. Oh, wow. I mean, that's at least okay if it was an actual question asked in class. The differential equation thing, I forget exactly what it was like, but it was like, it had to do with exponentiating derivatives. It was like, oh, what was it? It was something with a form like e to the a d dx equals something, but apparently this was valid notation, and it, oh, was it equal to d to the n? It was something like this. But it was some notation that I've never seen before that had to do with multiplying derivatives. Like, they were actually saying like d by dx times d by dx is equal to the second derivative, I think was the theme. That's it, yeah. And so yeah, for whatever reason, this is okay to say, and I don't know why. Or this one that comes up so often in maths. Honestly, oh, actually no. In differential equations, you definitely use it. But I haven't encountered that much personally outside differential equations, I don't think. But it does come up a lot there, to be fair. When I took calculus, I read through the book as soon as I got it. I taught my friend derivatives and L'Hopital's rule, then used L'Hopital's rule in every problem. On our first limit test, and the teacher marked everything wrong. Oh, that sucks. I'm trying to think if I would agree with, like, if I was a teacher, would I do the same thing? I probably want to talk to the student and see why they used L'Hopital's there when it hadn't been taught. Because that could be an indication of cheating, maybe, is what they were thinking. For a big and interesting, I'm prepared to prove L'Hopital's rule. Okay. You slay, syntax. What was I doing for filler? I don't want to do more physics right now. I could look at more of Dr. Cook's calculus problems. We did all the quote unquote easy ones that, you know, Cook's definition of easy is like Feynman and integration. So let's see what the hard ones are. Find this limit. Let's get into paint. Load her up. I mean, that seems more fair if you're like proving it, I guess. Wait. This seems like it should diverge, shouldn't it? Isn't this approximately the harmonic series? N equals 1 to infinity? Oh wait, no, K is what's... No? I think I'm misreading this. K is what's changing in this series, but N is what the limit is. Maybe I don't think I'm interpreting that right. Yeah, I'm not interpreting this right. Okay. It's more like 1 over K. It's more like oh, it's more like 1 over K squared, which has a known sum. But this thing with ends is kind of weird. My physics textbook has a statement about how nature minimizes, and I'm debating whether that's enough to invoke Lagrangian physics in the entrance exams. Oh my god. Each of the terms is between n over n squared and n plus 2n squared. Sure. So between 1 over n and 1 over 2n. But there are n of them, so some between 1 and 1/2. Huh. Okay. Compare the Riemann sum of 1 over 1 plus x squared over some interval. What's a good... I think we need to choose, make a good choice of interval here. 0 to 1 is my instinctual choice. What if I'm stupid and I don't know function transformations in my head? You're just shifted to the left by... Wait, what? Oh, it's not a transformation of 1 over x squared. I see why. Okay. That could be 0 to infinity then. You might want that. Probably going to want a k over n. Doesn't have to be ln2 that Dr. L will be here to enjoy it. If you want to Riemann sum, right, because that's our interval width, right? All right, we could try and conjure up an n over k. Oh, wait, so if we're comparing with the Riemann sum, we're going to find an integral in this thing? Is that the point? I don't know. So if we want to force there to be a k over n, what needs to happen to the rest of this thing? We can use, no. I'll be like n squared over k? K squared plus n squared. The Euler-Lagrange equation was developed in the 1750s by Euler and Lagrange in connection with results of the Tautochron problem of determining a curve on which a weighted particle will fall to a fixed point in a fixed amount of time, independent of the starting point. Huh. Interesting. When I think become a Riemann sum, then let me be an integral like that. Factor an n squared out from the bottom. Okay. Oh, that'll make it look a lot more like this thing, won't it? And so I want to make this 1 over n times k squared over n squared plus 1, I assume. And this is our interval width. And this is our function. I'm putting infinity up top. I should. Okay, yeah, and so this is... I can see that. I can see the relation between k over n and I guess the x there. And so this one we need to remember there's like, well, as n goes to infinity, I think we can make this statement, but we need to figure out what the bounds are. If the general public can't tell between Neil Armstrong, Louis Armstrong, and Lance Armstrong. Feels bad. Get it? Where's the one that they give to like calculus students for the first time? I can try syntax, yeah. These problems are kind of a weakness for me, to be honest. God, give me the simple explanation, please. There. Riemann sums for idiots. Yeah. I can render it. I was gonna plug it into my Discord so the bot renders it, to be honest, but that's fine. Oh, wait. Is our start point n and our end point infinity? Or sorry, 0 to infinity? But you know, obviously the limit as it goes to infinity. Is that what we're doing? That feels right. We just get pi over 2? That's too high though. Megalomorph figured it should be between a half and 1. My weaknesses are chocolate, beautiful woman, and staying on task. Recognizing some as Riemann sums too easy. 0 to 1? How? So I know I've seen in other problems, you have to remember there's invisible 1 over 1 minus 0, but I thought that's what the n was serving. Our delta is 1 over n, and we have n deltas. Hey, Jayesh. I still don't quite see why, but 0 to 1 is my other guess, because that's just a really common thing for these problems. Arctan of 1 is pi over 4. And arctan of 0 is 0. Yeah, sure, Jayesh. You can put it right there in the YouTube chat, or you can put it in my Discord. You plug in k equals 1, you're getting f of 1 over n. If you plug in k equals n, you're getting f of 1. Really? Let me just actually write this out. I don't know if that's a helpful thing to write it as, but whereas f of 1 over n, 1 over... Oh, okay. Well, no. Oh, okay. We're only looking at that. That's right, because that's the delta. Okay. That makes more sense then. Then if k equals n, get 1 over just 2. And oh, and f of x equals a half at x equals 1. Okay, that's a nice way of figuring it. Thank you. So this fall semester, I feel like I already forgot all the calc and differential equation I speedran during summer. Oh no. ethylene diamine something acid. My friend borrowed money from me and is now refusing to give it to me. Well, the money's probably gone, but you shouldn't be friends with that person anymore. Can you prove the sum of 1 over n squared is pi squared over 6? I can look up a proof. I don't know it offhand. All right, thank you for the help on that one, Mega. Oh, let me, well then what's the question then, ethylene? I thought you said he's refusing to give it to you. It's the basal problem. Dividing through by x gives that. The Weierstrass factorization. Oh gosh. I think Google's gonna have a better explanation than me. Pi squared over 6 might be beloved. Oh, that link has gone bad. Yeah, JH, I'm sorry. So I don't have a good explanation for you, but there are a lot of resources to this on Google, so I would just look it up for yourself. I'm sorry I don't have a better answer for you. Syntax error, you put that LaTeX in chat earlier. Let's render it. A math SE thing paired with like 20 different proofs. Oh, okay. Yeah, if you can. Okay, so you have... Oops. The limit as n goes to infinity, 1 over n, k equals 1 to n, n over k. You want to interpret that as a Riemann sum. Oh, thank you, Mega. So JS, this is a link that I'll pass along to you with a bunch of different proofs for the sum of 1 over n squared. Oh, that's in those. Oh no. The fractional part. I thought those were just there for I don't know, like clarity on what's actually inside the summation. Oh, that's a harder problem now, isn't it? For zeta 2n and only 2n to the power of pi and Bernoulli numbers. Yeah, this is the fraction part, JS. Feels like it should be 1/2, but I'm pretty sure it ain't, so. So do we want to think of this as k over n inverse? I don't know if this is right. I'm just spitballing here. It might be 1 to infinity. No? Yes? Desmos says it's 1. Try breaking it, JS says. I'm not sure what that means. Okay. So JS is suggesting to think about making this statement. You drive that part through this? Oh, okay. You're talking about the floor. Okay. Après ray? Probe zeta 3 is irrational. Proves zeta 3. Zeta 3 is irrational 979 fairly recently. We don't know zeta 3 over pi cubed is rational. Okay. Say we draw a picture looking at n over k versus fractional part n over k versus floor n over k. I say that Desmos draws the picture for us. Can Desmos do the fractional part? Actually, oh wait, but what is the graph of n over k? So I'm just imagining is 1 over x. And graphing like the various parts of that. Oh, right, yeah, I can always use the floor. N over k looks like n over x? Okay. Ooh! And it matches exactly after 1? I must go deeper. Take me home. Then we're doing a Riemann sum type thing. Oh, of course, the fractional part wouldn't have an effect at all. Yeah, duh. After 1, okay. So it'd be convenient if this integral is from 1 to infinity, in terms of computing it. Whew. What's the floor function doing? I guess what you would expect. Oh yeah, no, I know the floor function. Sorry, I misphrased the question. I'm just thinking about like integrating the floor function and how would that work if we tried. Hey, Licketh. That's what's happening with the floor function. Because I mean, I'm still terrible at figuring out what the bounds of this integral should be. If it's 0 to 1, we've got issues. If it's 1 to infinity, we can just do that directly. We're looking at n over k, not 1 over k. Well, that's going to be n is stretching? Question mark? Okay, yeah. Are you saying, oh, I'm implicitly canceling the... I mean, I thought the 1 over n is the delta, and we don't worry about that. That was the rationale for leaving that behind. So, and I was thinking of just this thing as being basically 1 over x. You have conjecture about the value, but you can't prove it. That it's 1/2? It's for integrating from 0 to 1? Oh, man. It's 1 minus the Euler-Mascheroni constant. Oh. So I don't know that integrating the floor function is going to work. Oh, sorry, the fractional function. Integrating this thing seems possible. Oh, does the Euler-Mascheroni constant come from this? No, I mean, I've heard of the Euler-Mascheroni constant. I know nothing about it, though. Comes from the left one? Oh. Hmm. For all I know, it may as well be 1 minus gamma. Oh, from here? One over floor x is going to be a little different from floor 1 over x, right? That's an issue. What's the suggestion, JS? Look if that's a question about... Do you have a 3-dimensional line and you have to find values of a value of p so that they're at right angles? I don't know how to do that offhand, Licketh. I might be able to figure it out after this, but I'm not sure. But I'm going to figure out what that means. J-ish. R over n equals x. For the integrating part, put 1 over x equals t and GIF in greatest integer function. Not sure. It's related to the amount of factors for numbers below n. Hmm. Yeah, I'm not sure syntax. Yeah, sorry, I'm about to give up on that one because I'm not sure. Like, I'm not sure what to do with it. JS over in the YouTube chat is saying, if I'm not wrong, the integration will get converted to the log of floor 1 plus x series. JS is saying that, I guess, the series for that might get involved. To finish your complexity in linear algebra course, you have so much free time. Okay. Integration I can generally help with. Like if. Oh, not floor, just the... Okay. Sorry, I saw the brackets and I assumed. Yeah, there's... that one is just regular log series. 5 streak, nice. Well, no, Anders, we were just like one-upping that. Syntax errors, that's about the fractional part. And so we were thinking about how the fractional part is equal to the regular number minus its floor. So next is about converting this into an integral, but I'm pretty terrible with these questions, and you get you seemingly get a pretty impossible looking integral. I don't know how to do personally, at least. But you do get a cool looking function. That green one. Try to simulate Scaltra. Okay. The original problem is, how do you interpret this as a Riemann sum? And these brackets are the fractional part of n over k. Or like, yeah, like converting it to an integral, basically, from syntax error there, chat. Sorry for the loud engine. Live, love, integrate. Oh god, we need a sign that says that's what people can put in their houses. Yeah, what are some good like math L words that could replace like live, laugh, love? I can't think of good like single syllable ones. Line. Line limit limps up. I guess Zach can have that one. He likes analysis. You've been some substitute work after you've been a bit in uni. That's neat. Substitute work like substitute teaching? Or what does that mean? Yeah, awesome. Yeah, that sounds awesome. It's just an awesome choice, but that's great that you got asked it to do that. Or you sub. Either way, you'd be happy. True. I do want to wrap things up in a couple of minutes here, but I want to give Megalomorph a while to work on his thing, and then Likith may have a question on integration too that I want to see if that gets put in there. The personal human calculator math slave. E&M dream job. Oh god. So I want to start looking at this other problem from Dr. Cook's like worksheet here, but you're writing? Yeah, no worries, Mega. I'm not going anywhere that soon. Oh, this is another Feynman? Okay, let's see if we can do a Feynman, I guess. I need to look at his first worksheet where he built the technique for you. Here we go. So we get the function given to us. We take the derivative with respect. Wait. So here, x, we're given an integral in terms of a in this example, and we include an x. But this time, we're given a function in terms of x, and we insert the alpha. Yeah, Feynman. I'm pretty sure that's what this... I don't think... This is a worksheet from Dr. Cook. I don't think he actually calls it the Feynman technique, but as far as I know, this is Feynman. Feynman. I don't know. I've heard people say Feynman, so that's how I always say it, but it looks to me like Feynman. Okay, so then you take the derivative of it with respect to the parameter that you insert. So we're given f of alpha, and we want to find df d alpha. Pretty fine, man. True. 0 to pi over 2. The derivative of this with respect to alpha what is this? It's going to be 1. Okay, let's bring the 1 over cosine x on the outside because it's a constant for the sake of this. So it'll be 1 over 1 plus cosine alpha cosine x times minus sine alpha cosine x dx. Mr. Manhattan Project. Was he working on the Manhattan Project? I know he did a lot of physics. I feel like I'm saying Manhattan weird. Manhattan. We want to actually evaluate this integral. Derivative with respect to alpha. Right. And then we integrate with respect to x, and we'll get something in terms of alpha. The cosine x is actually cancel. That's an... ugh. Okay, that's not... That's possible to integrate. That's really annoying, though. That's a wire stress sub. Ugh. Wait, I am thinking about the right variable, right? Dx? Right, okay. If we could just integrate with respect to alpha, that'd be a lot easier. Ugh. I wonder. Does this happen to be in the table? Not with a constant on top. Wolfram Alpha, save me from a virus stress sub. Oh my god. Inverse hyperbolic tangent? I had to have done something wrong. No way in hell we're expected to do that, right? I mean, these are the hard problems, I guess. Depends how, like, how mean is Dr. Cook really, I think is the question here. Did I do the derivative correctly? Cook be mean? This looks mean. You can do it easily. I don't see how. Hey, Dipayan. Cosine 2x in terms of tan x. There's a half angle with tangent? Let's see. Or for doubling over cosine with tangent. Oh, yeah, no, I know that technique, but it gets you a really stupid looking answer. Like, I fast forwarded it just to see what Wolfram Alpha would get, and you get this. I don't think I'm supposed to get that. I know how to have to do that tangent x equals t sub, but I get you a really messy looking answer that I don't think we're supposed to get. Oops. I think I did it correctly. You run through the derivative with respect to alpha again. Oh, I didn't know a different. I did not notice a difference, Fembox. Practice that a bit to get better with it. I kind of want a tablet. because it does start to hurt my arm if I use paint for like a 5 or 6 hour stream. And like paint with a mouse. And I'm kind of done with the whiteboard, at least for now, so. Have you tried the book Putnam and Beyond? No, I'm not that interested in like Putnam type problems. Wait, is one getting confused about what A and B are? Is that why it looks so stupid? No. Okay, maybe before my output is bugging and I should just look at what a wire stress sub actually looks like. Any physical significance? Do I know of any physical significance of harmonic progression? I'm sure there is one because of the name. I don't know offhand though. I bet the Wikipedia page would have something. No, it wouldn't. Harmonics, I mean, so I assume like this is the thing, like that's why it's called harmonic. I mean, that looks harmonic. One half, 1/3, 1/4, 1/5, 1/6, 1/7. I don't know. If I was like linking to this page, that's probably a decent jumping off point. But I don't know offhand of a good like answer beyond that with actual like harmonics. Or is that nice song in your playlist? I believe it's called After Dark. It's nowhere in the... I don't think it's played today, has it? Oh, I see it in the queue. It's way after. Let's bump it up. Actually, you know what? I'm just going to add to queue. And that'll bump it forward. There we go. Nah, it'll be like another hour or something before it's up. Let's skip forward. Oh, that's something that I want to set up at some point, Anders, but I've been lazy, I guess. How harmonics solve the Riemann hypothesis? Easily. I'll even turn up the music a little bit for you. In India, Don means mafia boss? Really? That's kind of cool. So someone just asked what the physical significance of harmonic progression is, and now this is my only idea on this page. Outside of that, I was working on a problem from Dr. Cook involving Feynman integration. And I think it needs a wire stress sub. Yeah, I've heard of that, like the dawn of a mafia. I know the thing in India as well. And I know in like in Spanish, it's not necessarily like crime, but like dawn is a term of respect. Hey Neon. Took right up your idea. I'm working, I promise. If you need to go, oh well. Okay. I mean, I want to see if I can work out this Feynman problem. So, and that'll probably take me some time. Minus sign alpha can just come out front. Yeah, Jayesh, I'm just concerned it's not going to come out to something clean, but I don't see anything better than to try it, so 1 minus t squared over 1 plus t squared. Oops, I'm not. And then what's the integrating factor? It's like senor? Okay. I just remember hearing it on Breaking Bad in one of my friends also has like told me about it. Dx is 2 dt over 1 plus t squared. Okay, nice. Don Quixote. Oh my god, I never connected those dots. You're right. Limits are 0 to 1. Yeah, the side I'm looking at says x equal, or wait, t equals tan x over 2. So if x equals 0, tangent of 0 is 0. If x equals pi over 2, we get tangent of pi over 4, which is 1. Okay, nice. We get 2 up there, don't we? 1 plus t's, oh my god. Why can I write? Cosine alpha 1 minus t squared. We need to rearrange this with powers of t, don't we? I've heard of it. I never read it, but I know that it exists. I know it's like a super like famous book in general. 1 plus cosine alpha plus 1 minus cosine alpha t squared, I think. Hey, Schlelo, it's been a minute. How have you been? Cervantes wrote I bought it because it was a classic. Yeah, I probably should read it at some point because it is just like such a well-known book. Okay, I think so far so good. And this terribly messy looking integral should be some version of arctangent, right? She can't read it. It's written in very old Spanish I can't understand. Really? I guess it's the same thing. Like people can read Shakespeare, but I sure can't. It just may as well be a different language. If you go like even but before like Shakespeare, it gets even worse. I've seen like YouTube videos of people speaking what they think English used to sound like, and it's crazy. Art Shakespeare? Oh my! I did everything I could to avoid Shakespeare. Integration is hard, bro. Sometimes it needs crazy intuition. Yeah, you got that right, Tipion. Dost unto hath thou thee fare thee well with. Yes. Okay. Let's absorb that negative sign into the denominator. So that's I never remember that formula. Like I use it a lot. I should just know how to derive it, but I'm too lazy. I don't. Is the plus T important? I don't remember. But oh no, it's definite. It's definite. So T is going 0 to 1. Alpha is not. That's terrible, dude. Arctan of 0 is 0, right? That's gonna. Yeah, it is. Okay. So we get df d alpha 2 sine alpha cosine alpha minus 1 root 1 minus cosine alpha, or 1 plus cosine alpha. Arctan monstrosity. That's what we get after we evaluate the bounds. So am I supposed to integrate this thing with respect to alpha? The channel's grown. Yeah, thank you, Schlelo. Closing in on 1,000 followers. There's even a little like thing that I like even more than my growth is that there's a little community of math people like math streamers out there who I'll do like a math help. So I was about to say now, but a lot of people have been streaming for longer than I have. But there's a little like community of us. Miquel de Cervantes y Saavedra, el autor de la obra cumbre de la literatura en lengua española. I don't know what that means either. Trying to Spanish for a while and an excerpt from that text. Okay. So I feel like I'm not right because, or I did something wrong before this because like, am I seriously supposed to? Like I'm not entering it with respect to alpha now. The root value is tangent a over 2. What do you mean? It equals 0 at tangent a over 2? All right, I know what you mean with that, J-ish. Seeing scaled rolling. Okay. Obra cumbre. Yeah, I don't know what that means either. Okay, let's look at what megalomorph drew up here. It is that, okay. Right, this for syntax errors thing. So the integral this resolves to is integral 0 to 1 fractional part 1 over x dx. It's not quite complete, but it has most of the idea. Okay. Dipion, you can put it there in chat or in my Discord. I'm going to wrap things up after this, though, so I might not be able to get to it today. First pictures of the integral is the black pieces. Oh, yeah. Okay. Okay, fair. Oh, interesting, J-Ash. Okay. I see what you mean with that now. Oh wait, okay. So I'm gonna keep on working that integration problem then, because that might be cleaning up really well. Taking the integral of 1 over x, subtracting off the right parts. Right, and so that's the same thing as the idea with the fractional part being equal to the n over k minus floor n over k. Oh, the integration square root of tangent. I can't do that integral. It's a crazy one. There's videos on it. I think Black Pen Red Pen has a video on it. I would watch that. So what are you doing on the right side here? You're involving the 1 over n with the n over k, sure, and then putting k over there. Okay. This first one is h sub n. Ignore the right side? Oh, okay. You end up using? Okay. So maybe I'll look down. We have a second picture. Oh, right there. Okay, yeah. Definition of gamma. As in the Euler-Mascheroni constant. Is that? The definition was the integral from 0 to 1 of 1 over floor x minus 1 over x. Taking the integral of 1 over x from k to k plus 1 and subtracting 1 over k plus 1. Essay in Spanish once when I took a Spanish comp class, but I withdrew about halfway through. Oh dang! I'd love to learn Spanish. I'm pretty terrible with other languages though. Taking the integral of 1 over x from k to k plus 1, then subtracting 1 over k plus 1. Okay, JJ, I am gonna return to that based off what you said, but since Megalomorph drew this up, I just want to take a look at it first. Both things end up giving the same thing. I would love to learn. Your English is great, Anders. It's way better than my Spanish, let me tell you. Can write it, but you can't speak. I mean, I've spoken with you before. Like, you were perfectly fine. Since this makes sure I can count to 10 in Spanish. Hey, that's something. So, is this, are you saying that this integral here is actually just gamma? I'm trying to piece together what these pictures mean still. You think it just evaluates to gamma. Okay. The second picture is the definition of gamma. All those things added up. All right, Jayish, I will. Thank you for the guidance there. Do each of the sum of the little pieces. I assume if the syntax error isn't typing, then I might have gone to bed. Oh god, I don't know why he was here. I'm pretty sure he's in Sweden, so it's probably super late. I think he's in my Discord though, so I could send him a screenshot of like this left side here. I don't know his Discord name, but if I put in that discussion, he should see it. Hmm. Actually, do I know syntax error's name? If I do at syntax, no. I think syntax error's name in Discord is something else. I just writing a little note for syntax error in my Discord quickly, and then I'm gonna see if I can simplify that thing in the Feynman integral. Um, okay. Let's put a little note there. Thank you for working that, Mega. I can feel my stomach like growling right now with hunger, so that's why I'm trying to like wrap things up soon. But Jay, in the YouTube chat, put a really nice simplification that I'm trying to find again. Right, so 1 minus cosine alpha is equal to 2 sine. Oh, was he saying alpha over 2? I think he might have mistyped it. It should just be the double angle identities, though. Let me look at them for myself. This problem so powerful, robbed down of your energy with any food in your stomach? It did. Yeah. Some dinner. I can't not solve this problem, though. It actually seems to simplify pretty nicely. I think Jay's just saying to take these two identities here, but instead of 2 theta, have just theta, and instead of this theta, have theta over 2. I can't not solve any problem. So that should be sine squared, if I'm reading the identity right. Yes. No? Yes. Okay. And then 1 plus cosine alpha is 2 cosine squared alpha over 2. And that's kind of perfect. Okay. Because it means our DFD alpha. JH, I'm just going to trust JH at their word for, what is it? Any sine alpha over 1 minus cosine alpha is somehow equal to cotangent alpha over 2, which we're going to need for this piece in front. So you're doing now about 20 minutes ago, the Blue Morin book. Oh, really? That's funny. So I think we have minus 2 cotangent alpha over 2. Actually, let me just verify this identity in Desmos. Oh. Oh my god. Look at that. Perfect. Okay. For this first piece, no. This piece, it does have a square root, but it's going to be 1 minus cosine alpha is 2 sine squared. Oh, no, no worries, Fembox. We're going to get just times tangent alpha over 2 for this chunk. Because it divides the tangent squared alpha over 2. And then we get an arctan tan alpha over 2. And tangent times cotangent is 1. So I get minus alpha? Now that does concern me. Oh no. JH said I should get minus alpha over 2. And it's possible JH just made an honest mistake here, but I am slightly concerned that I did something wrong. See if you right mouse? Yeah, if I do it for too long, my arm hurts, but that's the only issue. I don't think it's that hard to write somewhat legibly with a mouse. Maybe JH just didn't see I had the 2 in front. Where did the 2 come from? I think this is what I get, and I'm going to roll with it. Okay, so this is DFD alpha. What do I do next? Integrate the previous result. We're gonna integrate with respect to alpha. And then we have to go back to the integral definition to figure out what C is. So if we try to plug in 0, that's not good. If we try to plug in what's the value for alpha that simplifies this? There isn't one. 0. 0 would simplify this. So if we plug in pi over 2 for alpha, well, that's not good, but then we divide by 0. Wait. Yes. How can we... I don't see what's a convenient value of alpha to plug in here. Because we need to find f of something from this original definition is equal to something in order to figure out what this constant c is. Oh wait, no, I'm stupid. 0 isn't a problem, or pi over 2 is not a problem. Oh my god. Yeah, I was plugging the 0 down, I was plugging the pi over 2 down there because I'm just not the smartest cookie in the tool shed. And that's 0. Okay. So f of pi over 2 is 0. Equals 0 equals minus a half alpha squared plus c. Nope. Pi squared over 4. C equals minus pi squared over 8. That's actually... looks a little familiar, but that's not the answer. So we know that f of alpha is minus a half alpha squared minus pi squared over 8. JS, I get minus alpha at the end here. But other than that, it does seem to simplify as you said. Oh no. So f of 0 is the thing that we want. Actually, well, it doesn't have to be f of 0. It could be f of pi. No, not f of pi. It could be f of 2 pi. Let's try f of 2 pi. But it seems like we get different things if we do f of 0 versus f of 2 pi. This is a negative number. This can't be right. Well, crap. Well, okay. I could try to not be stupid and remember that I added this to each side. So that should be a plus. That's a good start. Minus 2 pi squared plus pi squared over 8. That's still not right. Oh wait, but no, f of 0. Never mind. Well, I don't know what was wrong. What I thought was wrong with f of 0. That'll give me the exact thing that I want. Okay. I was thinking I had to be fancy. Just do f of 0. 0 plus pi over 8 squared. Okay. Oh my god, and that's the answer. I don't know why f of pi over 2 or f of 2 pi doesn't work. I guess because it's outside of the bounds of the integral. JS, I bow down to you. I'm sorry I doubted you. I applaud your integration skills. Oh my god. I did not think that would... If I get something that looks like this, I think I must have done something wrong. And I... Apparently not, and Dr. Cook is just evil when he creates these problems. Those are some crazy trig identities to have to, like, notice. Okay. I gotta wrap things up now. I'm hungry. So yeah, JSN was here on YouTube. I appreciate you all. I'll be back. I should be back on Tuesday. We'll find out though. I gotta go get some food now. And JS, yeah, see ya and hope you sleep well.